Yes. No. Well, and I'll say this. So you're being recorded live, and so open mic. Ask what you want. I reserve the right to moderate. Never had to do it. I'll put the video up within an hour or a day after we're done here. So, expect to find yourself on a YouTube, Twitter link near you. Anything to do with compilers and language runtimes and garbage collection and typing systems and null or not, or whether concurrent means multiple threads or not. We just went around that one. It's all fair game. I don't have a set agenda. I had a fun conversation with Max Bernstein yesterday, where besides swapping apple cider for apple butter, we talked about compilers and implementations of Python for JITting, and what the hell I'm doing with AA typing and things like that. So I can start there if people want, or we can just carry on with what I was talking with Cameron about, which was add concurrent doesn't mean concurrent in ecstasy.
So what does it? So what does mean?
It means that it's concurrent.
Yeah, it's a lie. Yeah, doesn't mean two threads can run in the same code on the same data at the same time. That's not what it means.
Right.
Which is what I usually think when I think concurrent code.
Yeah, I guess it's the same time part.
Yes.
Right.
Yeah.
Or at least in
1990s
unpredictable
concurrency.
interleavings.
Yeah. Not.
You can totally have concurrent code on a single core.
Right. It's not
Right. So
unpredictable interleavings.
That's this meaning. That's what we're talking about. So think about a service
not
as being
parallel.
a single core
It's not.
von Neumann machine, and so you've got code running on it, and it can go do something via a message that potentially gives up control of the processor. So we refer to red and green. So when the code is red, it never gives up the processor. So it sends a message somewhere else, but it doesn't let anything else run.
Doesn't give
But
up
if it's
the control of the code it's in, not the CPU core, which the OS doesn't care what the hell you say and does what it
so
does.
I'm thinking the von Neumann, the pretend machine. It doesn't give up control of the pretend machine,
Okay.
the virtual machine. Here's another word that's overused.
Yeah.
So think about it. Each service is its own single-threaded, single-core virtual machine.
Yeah.
So when you say red, this is like the old school interrupts off.
Yeah, it's like CLI, clear all interrupts. You could think of it that way. Yeah, actually, the same reason, right? Because you do CLI in assembly because you don't want reentrancy in that code.
Yeah.
Right. So what was it? There was CLI, NMI. What was it? Non-maskable. Yeah, that was a while ago.
Oh, well,
I haven't coded x86 assembly in 20 years.
That's 86 only. I mean, I did this shit in 6809, which is a different set of rules, but it's fine.
Yeah, but
Same
that's
concept.
because it had a design. Intel
Yeah, they fell into it backwards. Yeah, fine. Okay, so the theory is at concurrent means.
So at concurrent means green, right? So when you come into a message comes into a service, and it comes into some method on that service, and so it starts out with the color of that method. So if that method is concurrent, then it starts out green. And basically, as it runs method to method to method, as soon as it calls another service, that opens up an opportunity for another fiber to run on that service. So as it leaves, think of it, it's not implemented this way, but it could be. As it leaves the service and someone else needs to get scheduled, we kind of backtrack through its stack frames and say, is this red? Is this red? And if any of them is red, then that fiber is red, which means the service is red, which means it can't schedule anything else.
Yeah. Okay. So, even if it has if the new guy coming in has unrelated data.
Right, but the service can't.
There is a bit of debate there.
Okay.
Right.
Yeah.
So 3 days ago, you could come back in, but you could only go in through other green code until you hit something that was red. And then as of 2 days ago, you can't come back in at all.
Okay.
And the challenge with that is you get spooky action at a distance. So let's say that you have a line of code which is calling method foo, and it's passing as parameters a call to bar, a call to baz, and so on. So it's calling methods, getting those results back, you know, in a temporary register and passing them to another function, right? The problem is that any one of those things that it's calling could be read. So it could literally halt in the middle of putting its arguments together for a function call. And that's what killed us, because there's a non-locality of effect from trying to optimize where we let green threads in, but not past the green-red transition. And it was also harder to optimize. So the way that what Mark's talking about is we had, let's say at a thread, it's running along and it goes into red and it calls somewhere else. We'd let green threads get scheduled, but we wouldn't let them transition into a red territory, right? And so it let us optimistically get more work done, but we had to actually do a check on pretty much, in theory, we'd have to do a check on every call. So the actual design for it was that we would actually generate code twice if there were contention, once for the service is still green and once for the service is red. So we basically use, we'd use code generation if we had to get around it.
But the whole point of concurrency is to extract parallelism. The whole point is to be able to get parallel.
Right. But
I mean, not
there's
necessarily.
no language today that gives you concurrency within a thread.
If you don't have parallelism, then why do you do it?
Because you want
Concurrent.
responsiveness. If I have 1,000 users that are all time sharing the same mainframe,
Yeah, okay.
I want to be able to
agree.
switch between them.
So
Okay, the time sharing.
Scala doesn't have concurrency within a thread. Java doesn't have concurrency within a thread. If I'm running along with a thread and I make a call to foo, my thread doesn't pick up someone else's activity and run, right? So that's the kind of
I mean, I can use Java's fork join library if I want to.
I've certainly used it
Right.
plenty, but that's big in the
But
question.
an arbitrary call to foo doesn't say, okay, I'm going to take the same thread, pause the call to foo, and grab some other thread's work and do it on this thread.
Yeah, see,
that's what
I think that's part of the model of what you call thread or not, right? It's all
Right.
fine. And as long as you keep it transparent, no one cares that you use the same core or the same OS thread or the same fiber or not. The as if rule applies and you can't tell. The question I had was, or the thing that got me confused was I saw add concurrent and I assumed, and you said concurrent hash map. Mark's making a concurrent hash map.
Right.
The obvious use case for concurrent hash map is you have 1,000 running threads, fibers, whatever, and they're all banging on a common cache.
Same here, right? So, but in ecstasy speak, it's you have 1,000 services. The services run in parallel on multiple cores.
Right.
They should all be able to hit the same concurrent hash map and actually operate in parallel on it.
Okay, that was my question then. What happens when and is that code declared at concurrent when the concurrent hash map sustaining high speed, rapid, low latency cache hits on a large common shared cache? Are those?
So there will certainly be parts that are concurrent, but and here I am 3 hours in, right? This is, like I said, by far the most ecstasy code I've ever written, which is all of 100 or something lines now.
Excellent.
But it's a partitioned approach, right? So the concurrent hash map is a non-service object. It just looks like a regular object, but internally it has a table of services, one per partition, right? So you right now the partition count is fixed, right? It's like, oh, well, foo is in partition 7, which is completely independent from partition 1, and those two can be operated on in parallel. If two things try to operate on partition 1, now they're going to
resizes.
They're going to within a partition you can resize because a partition is still backed by a hash map.
You can't.
But if you want to,
yeah,
you can. Yeah, you can. I'm pretty sure I can still dynamically change the table size. It will just be significantly harder.
Right? What is your
resizing? There, you'll lose parallelism. But once resize, you can go back to. But I'm going to work on the fixed partition count version first.
Yeah, let's say you guys have shot yourself in the foot by disallowing the obvious concurrent, really concurrent approach.
Yeah, it's just you just
everywhere.
need services.
No. You basically said I have to have a partition data set only. I mean, a partition hash table only that only does resizing by freezing everyone else out. Like non-blocking hash map is non-blocking and totally concurrent and resizes on the fly dynamically without blocking anybody and causing minor
Except
delays, minor latency issues while you're concurrency. And
completely
the code is,
non-reentrant.
I'm sorry?
Completely non-reentrant.
And it's completely reentrant.
No, it's not reentrant.
Non-blocking hash map?
Well, not concurrent hash map.
Yours might
non-blocking
be
hash.
reentrant.
Non-blocking hash
Doug
map.
Lee's.
Non-blocking is just totally fucking reentrant. Absolutely.
Sorry, I meant Doug Lee's, not yours.
No, right. No, that's what I'm saying. And the code is publicly available and there's lots of documentation. I'm happy to step in first. It's not hard.
Is non-blocking hash map reentrant in the face of the Java 8 APIs where you have like compute and can run something on an existing element? Because that's where concurrent hash map loses its.
No.
Yeah.
You have to decide how you want the compute to go when you have ties. And there are two obvious ways. One is everyone computes in parallel and then everyone installs and one guy wins the install race. And the other pieces of work are throwaway. And the other way you do that is
something with the map. Does that cause a problem?
I'm sorry?
It comes back in the, if the compute comes back in the, so the compute lambda has a reference to the map, comes back in the front door through the map API.
Not harmed at all. And in fact,
Awesome.
that's how the map normally resizes.
But there's stuff in the map API that I think kind of precludes you from being able to do this. I don't remember exactly, but compute's like, here's the current value. What do you want it replaced with? So if you have two of those things run in parallel and both are saying, I'm replacing 1 with 2 and 3, like they both didn't replace 1, right? The API breaks you from actually being able to implement it truly in parallel and meet the spec.
Somebody wins in that case, but I pass all the JCK, TCK tests with that map, and it's all reentrant in all ways. Concurrent, parallel, every possible. This is the state machine. This is the wonders and joys of state machine programming. There is no state. You cannot harm it with a stateful, I was in, so I came in again. I don't care.
So what does serialization mean to your map? So like Cliff's map, the level of atomicity is per key. I can't atomically change 2 keys at once, but I can atomically change 1 key.
Oh, you can atomically change. Oh, no, you're right. You can't atomically change 2 keys. You can concurrently change 2 keys, but not atomically change.
Right. You need some kind of transaction there. So I'm curious with your map, is it an atomic update of multiple keys or it's atomic update per key?
My intention is it's still, I mean, it's the map API, although it's the ecstasy map API, it's still the atomicity is at the key level, but you could say I can atomically modify 2 keys if they happen to be in the same partition, but you don't really have control over that. And of course, from Coherence, we have solutions for that, but I don't think that needs to be part of a general purpose map API. So just supposed to be a map that you can actually truly operate in parallel on.
So for Cameron's question, if you can come up with a test case, I'll tell you yes or no, but I'll bet you that the non-blocking hash map has no reentrant.
I'll have to look. So concurrent hash map, if you can like destroy the data structure doing some reentrant stuff. I would, if I'm remembering the map API correctly, I would imagine non-blocking hash map ends in a consistent state, continues to operate fine, but the operations that did the compute were lied to, right? Like somebody was told I replaced value 1 with 2, and somebody else was told I replaced value 1 with 3, and both of those cannot be true. Somebody replaced.
Right, you won't get them both. So if you come in with compute if absent, somebody will win, somebody will lose, and get told I ran compute with absent, and there was a prior value.
But like regular compute, and hopefully I'm remembering the API right. You were told you're replacing this value with whatever you return, but both guys can't do that.
I will win or lose according to whatever the
right. So somebody
gets told they got lost.
But that's not part of the, well, I should stop saying what I remember compute as being.
As far as I know, there's no, I only ever succeed. So Java 8 compute hash map, Java 8, there's nothing in hash map on Java 8. The word compute shows up in like compute if absent or whatever. Oh, there's a straight up compute and replace. This is what you're talking about?
Yeah, maybe it's replace.
It's attempts to compute a mapping.
Replace, yeah.
And
So do you just have get input on your hash map, or you also have cas?
I haven't gotten to those yet. Cam, what's in ecstasy
There's
map?
cas, yeah. There's cas.
Yeah, no, the compute says replace the current value with the computed thing, and they'll each get the, one or the other. If you come through with compute key, and I think I have an implementation for that. If you come through with compute key X and you do a computation, and then the key has changed when you come to install, I have to rerun the compute. So I'm saying there's two ways to run this guy on the compute. You either
So does the
rerun
the doc on compute say it can be run multiple times,
or you have to hold you throw down a cookie in the value saying I'm in the middle of a compute, and the next guy in has to block because it's a blocking operation. If you replace the map with a map of size 1 key and you refuse to resize it, and you only have the 1 key coming in, and 1,000 concurrent CPUs threads go do computes one after another, what's the semantics? Well, in practice, everyone's going to block while they take their turns one at a time computing after each other. Attempts to compute a mapping from the specified key.
It does. So yeah, at the map documentation level, it says the atomicity is up to the implementation. So therefore, yeah, your implementation is correct because it's allowed to do whatever it wants. So I withdraw my comment. It is it is not incorrect, just perhaps unexpected.
Well, you get handed the value you're computing on, and then when it comes time to install, you don't necessarily, actually, there's no atomicity there at all. No, this map, the compute I'm looking at for the Java 8 compute is totally allowed to do weird shit. Like the key is mapped to 0, and 2 guys come through, take the value and increment it and store it back. They both can read a 0, they're both increment to 1, they can both store 1 back. That would all be totally legal by the docs that I'm reading, and you'd get a 1, not a 2. There's nothing.
Yeah, I guess I always interpreted it as, in my compute function, I get to decide what I want the new value to be based on the current value. And like, that's it, that's the atomic operation. And your extension, which I'd have to read the doc again to feel like, is this legal? Is you say, if after I provided you with a new value, you see that somebody else changed the old value, you run my compute function again. That's a surprise to me. I didn't think my compute function was run more than once.
Right.
But I get how that's like,
no, but I'm not claiming that that's what needs to happen here. In the land of H2O, that's what I did. On a particular key, you did an atomic transaction from value to value. If the value changed, you reran the transaction. That's not the Java 8 compute. The Java 8 compute is, I took some value I have seen before, I did a function on it, I cased it back down as a value replacement, but somebody else might have read the value I did and cast down some other crappy thing.
So old value should have been documented as some prior value might not be the current value. That's
what I'm reading hashmap. Let me go read the concurrent hashmap docs, which might be. Sometimes they
well, and then I'm pretty sure what concurrent hashmap does to solve this is they lock the bucket while they run your compute.
So they give you more guarantees.
Yeah, so to actually give the atomicity, they drop the concurrency, but then you get in trouble if you re-enter, because now you still hold the lock, and so
I see.
Now you get to start screwing things up.
Okay, the method invocation is atomic. Yeah, so what I would do is, and I haven't implemented this because at H2O I just reran the compute. What I would do is not lock the bucket, I would lock the key.
Yeah, for some reason they lock the entire bucket. Right. But then again, there's not supposed to be that much in the bucket, right?
They already got locks and buckets if you're doing updates. They already locked the entire bucket up. It's one of the reasons that concurrent hashmap runs faster on high write volumes. I don't lock any buckets. They lock the bucket and you're limited to 1 write per bucket at a time, as opposed to 1 write.
That's only if it's like a structural change, right? If you're updating an existing entry, it still locks.
Yeah, readers can pile in all they want concurrently all the time. Writers always lock the bucket.
Right. I feel like there's always going to be some kind of contended key. And there tend to be 3 different ways that people want to solve that may not get the same solution. You have the let's all hammer on it like a cas, and if someone changed it while I was working, I'm going to rerun my compute.
Yeah, that's
there's the I don't want to run my function 18 times, so I'm going to make a queue of things that are going to update this word. And everyone just gets their transaction thrown into the queue, and I'm gradually going to work it off. And they get played exactly once because I already did synchronization in the queue.
Right.
And then there's I need to change A and B simultaneously, atomically, despite the fact that they're two different atoms. And now I need to play some kind of transaction game where I'm either doing a two-phase commit or I'm locking something.
Something's going on.
That's the painful one.
Right. I took the version that said that I expect your transaction to be cheap and side effect free, and I would just run it again. And this was the H2O version. The queuing version, as I thought about it and said, if you're playing this transaction game already, you probably already don't care, and I'll just rerun you. And
right. So Ecstasy is
kind of nice
queuing version.
It's kind of nice for a standard library to say, I'm going to give you a concept of an atom, and you can either call update on the atom and I'll take a function and do the churning rerun, or you can send it a message and it'll just wait until it gets a chance, or I can throw these things in a transaction. Like, you can imagine that you have a concept of a thing that goes through a linear sequence of events.
So reading the merge operation in the compute operation, the docs for concurrent hash maps say more stuff. The computation should be short and simple. And must not update other mappings. And I don't care. You can update other mappings for me because the state machine doesn't give a fluck. But I don't do these.
So yeah, at least they document that they're not reentrant.
Yes. And like I said, I'm totally reentrant here, and I don't care. But I don't do the queuing game. Although I could implement the queuing game.
Yeah, I think the queuing game would cause less problems for your hash map than trying to do a transactional update with 3 keys.
It's slower. Well, the transactional update is not possible without a major restructuring of a lot of things, because you don't have an atomic operation that covers multiple keys in general on any modern hardware. So immediately everyone has to pile in on a single point. We agree to lock here that's somehow related to your 3 keys or your 17 keys. I give you a number of keys bigger than Intel's whatever hardware transactional memory, right? Okay, you have to find some common serialization point amongst all those keys, and everyone has to agree to lock on that. And now you're locking and blocking.
So what I do for those use cases usually is use an atomic 64-bit value and use 61 of the bits as a lock table. So you basically cas for the bits that you want to lock, and so you take on it's.
What do you do?
So it's
1,000 keys you want to lock.
Well, that's the point. You pick a bit for each key. Okay? You OR the bits together, and then you cas from the previous lock value to the new lock value, which is the old one plus your bits. Right, if none intersect, and then if it locks it, then you own those keys and a bunch of keys that you don't know about.
Okay, so
you're locking the hash codes. You're locking the hashes, not the keys themselves. But it is an atomic operation.
I'm talking about you're talking about locking the ability to mutate the mapping from the key and the value. That's what I'm looking for. Okay.
Yeah.
And what happens if I hand you 1,000,000 keys I want to lock all at once?
Well, it's probably all 61 bits at that point.
Well, that's what I'm asking. How does 61 bits cover 1,000,000 keys?
Because each key has a hash code. You mod it by 61.
Oh, I see.
I see. Okay.
So you pile. So one bit covers many keys.
Right.
It's
According
a rainbow
to the table.
And you use the extra 3 bits to mean other things as well. Like one of the bits can be used for lock all. So
yeah, okay, no, right. I mean, I certainly had issues.
So it's essentially a Bloom filter. You've locked every key that your Bloom filter says might be part of the transaction.
Yeah, I got it. I was trying to figure out. So the obvious concurrency issue is I've totally had hash tables had 1 billion entries in them, and many shared hashes because you only had so many hash numbers. And locking them all kind of sounds sucky, but you only had 64 cores, so
great.
Maybe it didn't matter.
I will say my instinct to solve that was very different of make a thing, if stuff's close together, then block it into 64 that locks it. And if you have more than 64, then do it in 2 tiers and be like, here's each of my things that lock a chunk. And then here's my thing that locks all of the locks.
Yeah, which means that every time you did an access or an update, you had to walk multiple tiers.
Yeah.
This is sort of the latency trade-off versus other things. Like not like hash map, it's always one hit, one probe, and you're
Yeah, it's expensive, but at least it's expensive on the log 64 of the size of the.
Yeah.
Yeah, it's kind of a Patricia try of a lock.
Lockable chunks. Yeah. Well, you don't have to lock all the way going down if you're not being atomic across multiple keys. If you're just doing atomics on one key, you can just get down to the bottom and do one key. Yeah, that's reasonable.
But I used that 61-bit trick, 61 because it's prime, right?
Yeah.
But I used that 61-bit trick to do shared locks before Java had shared locks. And it was because each thread would.
You mean shared locks? You don't mean the synchronized keyword, you mean Java 5?
Read-write lock.
Read-write lock.
Read-write, sorry. Database terminology.
Yeah.
Shared versus exclusive. So bit 62 would be exclusive, and then each thread would take a different bit. And it would store that value in its thread local, and then to do a shared lock, it would simply cas that bit from 0 to 1.
Yeah, okay, it makes sense. Yeah, I had to deal with Azul and read-write locks, and you couldn't do the JDK 5 read-write locks because I had too many cores that went into parallel read. They would get contended on.
Did JDK 5 have read-write locks? I thought they were like
but by the time we were
7
doing
or 8.
Azul, we were doing read-write locks from, I want to say,
I think they were in Java 5.
I'm sorry?
I think read-write lock was in Java 5.
I think they were in 5 as well. Yeah, they came in.
Yeah, that's when the whole concurrent package came in.
Right. I think they were part of the base concurrent package. I think I was leaving Sun and moving to Azul and implementing still and talking to Doug Lee all the time about what was performant and what was not on what you could do.
Yeah, this week I installed Azul's
JDK.
JDK 17.
Excellent.
Hey, Arthur.
Yeah, I grabbed their JDK. I'm up to 15 finally because I wanted it for some reason. I haven't.
Yeah, I assume this is Zulu. This is just OpenJDK build, right?
Yeah.
Yep.
Yeah. I'm on the Azul build as well.
We have some new Macs showing up this week. So.
Oh, Macs. I thought Apple hated Java. Does Apple still?
Apple hates Java. Thankfully, Azul doesn't.
Right.
So I thought part of the hate for Azul was like for Java was JITting code was like forbidden or something. They have
that's
iOS, not Mac.
But then again, how long until it's on Mac?
So iOS is allowed to JIT. What it's not allowed to do is download code in JIT. So the code can't be user supplied and it can't be network supplied. But as long as the code is local, it can be JITted at runtime, and that does not violate Apple's terms.
Oh, I'm sorry. Okay.
And
yeah, it has to
shared
be in the
libraries.
blob that was reviewed by their QA
There's no
team.
shared libraries either, so you can't install a JDK on an iPhone, but you can embed a JDK in an app, and that's perfectly legitimate. It's crazy because, I was at Oracle when we were dealing with these license issues, and so we had customers putting a JDK in every single app.
Yeah.
So I feel like that used to be crazy, but it's not that crazy now. Like the Go binaries are big because they bake the entire Go runtime every time you compile into it. But
after you fold with Kubernetes, it's like, yeah, heck, I'll put 3 operating systems into this file. Why not?
Right, because I can deploy Go by just stick the binary on the computer and execute it. I don't think, wait, which version of the Python runtime is here? Do I have the standard libraries? Is this conflicting with the dependency of something else that happens to be on the same box?
The avoidance of DLL hell,
like
jar hell, just
statically linked binaries are kind of nice, and that kind of includes putting the VM in the binary with the code.
Yeah. That's true.
Yeah, when your smallest deployable unit contains Linux, the JDK doesn't look so big.
I was only up to the smallest deployable unit, included all the Java standard jar libraries, fucking Apache Commons and everything else on the planet. and the JVM all into one wad. I wasn't up to Linux.
I have to imagine there's Linux distros that are smaller than the JDK.
Oh yeah, I know there are small Linux distros, but that's not what I just heard. I heard like, yeah, we don't fucking care.
I've got VMs we deploy that contain a 5 megabyte Linux kernel and 20 megabyte Go binary. That's the deployment. Like it's 2 files, a kernel and a binary.
But if you had just the one file that included the Linux and the Go, you'd take it because it would have one less thing to confuse with. Life would be a lot simpler if you had just the one. Oh, tar them together and declare it.
Compile your AA straight down to x86. No OS needed.
Well,
just ship it on a hard drive.
Well, that's the point of having the OS. It has to be there anyhow. But if I'm going to run on some fucking VM partition anyhow, whatever the VM wants me to run on is what you need, which maybe includes a Linux. I don't know.
Yeah, just target the VM as your substrate.
Yeah,
what do you need an operating system for?
This is what you're running anyhow. So what the hell? What's the difference? That's what the OS was for. Was you didn't have to target the bare hardware. Now you don't have to target.
Particularly if you're in the cloud and you really are just only targeting the VM layer.
Do you have an update on AA?
Oh, well, let's see here. I had a long conversation with Max for the weekend. It was fun yesterday. The conversation ended with like, I went down the things I did with AA's typing and why, how many yaks am I shaving at the same time? Somewhere last week, I was like, unifying the errors that you get out. So if you look at a Hindley-Milner typed language and you run it and you have a bug in your program and you get a type error, the way they're typically handled is that you abort at first type error and somebody grovels around a little bit in the syntax and tries to come up with an error message for you. So in my world, I want to claim that dead code, I don't care what it fails typing on. So if your code is dead, it doesn't impact your Hindley-Milner results. So if I get type errors in code, I can't stop the process. I have to keep going in case the code turns out to be dead, which means that I get errors as a part of a normal Hindley-Milner type system. So if you look at the Hindley-Milner terms, for the typing language, you get ground terms, you get functions of args to returns, you get structs with labels to type variables. It's sort of, and you build collections of these. For me, I also include errors, which said I had two things which are not unifiable. Those are now a normal Hindley-Milner term. And I run through the Hindley-Milner standard result with this error term so that when I get out to the end, if the error term is part of the final result, I have a canonical same error message independent of what order I visited things. Because the standard operation would be, I visited things in random orders. I got whatever errors came first or second. In the normal Hindley-Milner, you blow and die. For me, I have to keep going. So I get all the errors all the time. And I want to have test cases that do golden rule things the right way. So I have to say this particular pile of text produces an error. It's the same error independent of the visitation order, same error everywhere. So I have to canonicalize and unify the errors. That was last week. This week, I ran into the first time I needed the DFA minimization algorithm, which is fairly commonly shows up in these Hindley-Milner guides. If you get to recursive types, I need an NFA or a DFA minimization, or else I don't necessarily get the same canonical minimalized type, which means the golden file test again blows because I have two cycles that are textually identical. They're cyclically equivalent graph equivalent, but they're not actually equivalent. So, finding that they are the same thing is actually a cycle equivalency, which turns out to be DFA minimization. It's not, I don't have to solve the general graph equality test. That's, NP complete. I'm solving DFA minimization. So I'm writing the DFA minimizer algorithm. Like I know what it means. I know how it works. So it's well understood. It's just a pile of nitpickies. So I'm busy implementing that. It's 3/4 done, or maybe even more. It's like 90%. I'm running down my large test cases and discovering places where I didn't get things quite right, and going back and fiddling, because it's not the exact Hopcroft-Ullman algorithm, because I have too many other things going around at the same time. So obviously I have to have stupid little extensions everywhere to deal with things. In particular, I want to be incremental and online, and what immediately means I have a large prior body of code, which I know has already been minimized with the NFA, DFA minimizer. I don't want to revisit it when I have a new pile of types to go with the old pile, because that would give me a horrific runtime. So I have to have an incremental online version of the DFA minimization algorithm. So that's where I'm at right now.
How do you have a how do you materialize the notion of a dead code? Do you have a type dead code, or do you have somehow keep track of them as you encounter errors? And when you encounter an error, when you see that's a dead code, you just ignore it, or how do you track in the dead code?
So I type the stuff in the Hindley-Milner side, and when it comes time to do unification of tests, I run across an if test that says if true, else false, standard Hindley-Milner, the true and the false arms are immediately unified with the result. And for me, it's I only unify the live side with the result. And in fact, to run.
So it's not that you have a dead code node, it's just that you have no node there.
I have no unification happening there. So multiple things run around here that are extensions to Hindley-Milner in a sort of deeply theoretical way. One of them is I'm combining the global constant propagation, which means when I come to an if test, I can tell you something about the predicate. So the predicate starts at a top, which means I don't know yet. And so I don't do any unification on either arm. And then it falls to one of true or false. Okay, at that point, I begin unifying with that arm with the result. And then it falls again, maybe to get both arms, and everybody unifies. But if only one arm's unifying, the other arm internally inside of itself unifies, maybe to an error state, maybe not, I don't know. But it doesn't unify with the result until it's known to be executable. So there's that version of live or dead. The other thing going on with live or dead is the classic backwards flow, which I'm also running in the optimistic way with global constant propagation at the same time. And I can tell you that any given node at the moment is currently considered dead, and then I don't unify it. So the node exists. During the running of a top-down algorithm, everybody all exists, but you just carry information, and you carry two pieces conceptually different. One is a lattice type value, which is just for this node, which includes its forward flow values and its backwards liveness value. And then the other piece you carry is a Hindley-Milner type variable, which points to a large interconnected structure of Hindley-Milner types that other people are also connected to, a large shared common thing there. And then the steps you take when you see a change in some of your neighbors depend on, you know, if you're dead at the moment, then if your Hindley-Milner type changes, you don't further unify it with your neighbors because you're dead. You don't have any, you don't imply any constraints on your neighbors' types. That makes sense. And then once you become alive, you start unifying with your neighbors, and that forces you to become part of the larger solution state.
So is this algorithm sensitive to the entry point?
I'm not sure what you mean by that.
Do I assume that I'm going to try and run every file, or do I start at main and just see what code I discover?
Yeah. So you start at your entry points. So it's with module, but you can claim the module's main. So let's start with main, but works for modules just the same. You have an entry point. The entry point's soon reachable by somebody who's going to call you with all possible arguments that are legal. And then you flow forward from there. You have other.
So I do need to have a list of what are the things that I'm exporting.
Yeah.
Because those are all essentially starting points.
That's correct. So you have to have an export list. But that's like, I'm making a module, I'm going to list the exports. While I'm developing the module, I had a bunch of internal entry points that were only internal. Turns out some of them were dead, never called. I don't care. Then they don't participate in the typing. But they're in the text file, so I process them and I come through. Maybe they're callable. So along the way, while I'm doing this, I'm building basically a call graph at the same time as everything else. It's all part of the one pass big shmoo.
And if I import a library that's got a lot of stuff that I don't actually call, that'll all just be dead and not actually show up once I compile it.
Once you compile it, yeah, right. So the theory here is that the library types internally, assuming all callers can do all things callers can do. But when I type against it, I will only have to incrementally test the pieces I use. And then everything else the library does will have no constraints on me because I'm not reachable to those parts. So in particular, if sections of the library demand certain funny arguments, but I never call them, I don't fucking care. But that's just, you normally get that out of C code anyhow.
So instead of reachability analysis, you during typing you discover what do you use in the library while you type it.
I'm effectively doing reachability analysis during typing.
While you type, yeah.
I'm doing a very aggressive version of that. So standard conditional constant propagation.
Yeah, I think this will do better tree shaking than most of the compilers that are widely deployed.
So as far as I know, I'm going to get what tree shaking does.
Yeah, of course. And it's more efficient because you do while you do most of the other things.
Do all the other work at the same time. Yeah, right. And you know, theory says it's pretty close to linear. Hindley-Milner can get types that get big. And I've done some work to make that more efficient, but I think I can still get large Hindley-Milner types that exceed linear size, which means that your runtime is however big. But in practice, Hindley-Milner types don't get big. The worst case test cases you produce get big.
Yeah, they rarely get big.
They rarely get big. Some of the test cases I grabbed from the internet that say this is how you get Hindley-Milner to get big appear to blow up for me to the n squared level instead of the n cubed level. So I've done some efficiency hacks there, but they don't. I don't claim that I'm not provably n squared. That would be a major Hindley-Milner type improvement, is to provably be n squared. I don't know if that's even possible.
As long as the types remain on the practical side, I doubt you will have a problem typing.
Yeah, and then right. For all the normal things I'm doing, the types are all normally sized and it's all.
Yes.
Yeah. Mm-hmm. So to answer the question, what am I doing with the AA? Well, the moment is I'm still back to the land of typing because I had to go unify errors. Okay, I guess the other piece that came out of this was that I hit some set of funny bugs, thought I should have caught them earlier with my tests, realized that I have been running the tests with, they're all work list algorithm, but that they should be work list independent. So I beefed up the tests to run with random work list numbers multiple times. So I take random seed and I pull from the work list according to random seed. Well, that immediately popped up a bunch of different errors that were stupid things that were left, right, here, there. Then it popped up things that I wasn't canonical at that I should have been. That eventually turned into errors had to be canonicalized, which got me down this path. So at this point, my testing is a lot more robust. Every possible test I have now runs with a variety of random seed keys every time I run the testing. And they're all passing up until I get right now the DFA minimization algorithm. And I've been yakking a long time and I haven't been looking at the doc. Is anyone doing any doc timing? No one's touched the doc timing. Crap, it's 45 minutes.
I do it. I do it.
Oh no, someone's been doing it. Oh, it didn't update. Just now updated what I think there. Wow, look at that. Thank you.
I have been done it.
You have been hacking. Thank you. Sorry, I flipped to it and Google did some lazy update thing and like, you're not looking, so I'm not updating it. Oh.
Yeah.
Yes, Google Docs has gotten lazier. It used to be pretty rare that you would click the thing and suddenly everything would jump, and now that's pretty common.
Now it's pretty, okay, yeah.
Which I'm sure helped something somewhere, but
yes.
Yeah,
yes.
Speaking of concurrent.
Yep, fine. Oh yes. Well, I thought you were about to go. I thought I was going to add something there. Fine.
Concurrent document.
Yes, fine. So the other piece that came out of that conversation about AA was the set of things I'm extending Hindley-Milner with. So I have standard Hindley-Milner. I've extended it with labels and structures, which is a well-known thing. I've extended it with nil, which is not an object or a maybe wrapper or a result wrapper or an option wrapper. It's nil. So the wrappers collapse. This has also been done by other people before. I'm extending it by dead code. Dead code does not unify. I'm extending it by unreachable code does not unify. My ground terms, my base terms are anything from the lattice, which is distinctly different from the int, float, string primitives you normally get. Errors are conceptually unified as well, but they don't count because if you get an error term, I'll stop you after the typing and not proceed further. But I will guarantee canonicalized errors. So I do have a Henle-Milner adjustment to make the errors canonicalize.
Do your labels distinguish between API facts and ABI facts? So if I'm like, I have a thing that's A that represents a number between 8 and 22. Does it care whether that's represented as 8 bits or 16 bits or 32 bits?
Oh, you know about size? No, right now I haven't done any work on letting you demand structure layout. So yeah,
so I can always unify an int 8 and an int 64.
That's correct. So actually it's a different question. So yeah, so if you have an int 8 and int 64, the unification will go to the lattice and do a meet. And that'll give me whatever the meet of those two lattice elements are. And the lattice is complete, so there's always a lattice element for that meet. There's also a question of, do I want to let you force layout because you want to have something outside the type system is exciting for your layout because you're overlaying bare hardware. You are, and you're talking directly to hardware registers controlling UARTs or graphics chips or whatever. Or are you trying to?
Or I just have an array that I really want to be an array of 8-bit things.
No, array elements. Arrays are size, which goes straight to. So I am letting you dictate array element size. And when you store something into array element, there's rules by which I'll just silently truncate. So the usual being, if you got an int and you're storing it into an int array of an 8-bit array, you only store the low 8 bits, and no one complains. And you could argue that I should complain saying you have to explicitly truncate, and maybe I'll do that, maybe I won't. That's a different question. When do you complain about doing the truncation rules? But if you're doing a double down to a float array, I'll probably demand that you round it before you store. Maybe I'll do that for the ints as well. I guess there's the other way coming out for the 8-bit guys. When you pull them out, they'll silently extend as 8 bits do to whatever. So now that you have an 8-bit array, there's unsigned and signed, and that goes to how the silent extension happens, which I think is also well understood and no excitement there. But do I have a struct and I want to demand field sizes or field layouts? That's different.
Yeah, I almost want to give people deliberately clunky stuff if they want to specify a layout. And be like, yeah, if you use braces, you get an API thing you're declaring. And if you want a real struct to like type in syst.struct of whatever.
A C struct or something.
Yeah.
You want to have a forced layout. Yeah, probably there's a separate syntax that says this is a forced layout. It has padding rules according to the rules you specify. Empty holes I cannot fill with other unrelated things and shit like that has to happen. Yeah, we could go there. I think that makes a lot of sense. There's a use for that. There's clearly a use for that, but it's certainly sort of minimalized. There's another version of that.
Most of the time, I only care about API. I don't actually care what the shape in memory is.
Right. Yeah. Right. Exactly. And Java shuffles fields around according to what it packs them in and does alignment, fills the holes with later classes filling in fields and holes in earlier classes. Like no one cares, no one notices. It's all fine. So I was going to say there's a concurrent ping pong padding thing that sometimes, very rarely, you want to have an automatic padding thing or force a padding. And Doug Lee has this forced padding game where he just puts a bunch of fields in a row and a struct, claiming that he knows the VM will take these fields that no one writes to, no one reads from, no one ever looks at, and they'll still pad out the object, and that will force this field and this field to be a cache line apart, right? And of course, there's a JVM optimization sitting on the table of every engineer, which says all these fields are never used and all set to 0. So I'm going to yank them all out of the core object and just
can that be done if they're accessible? Because when I do that, I leave them as package protected, so that theoretically a class could be introduced that could access them, assuming that means you can't optimize them out.
No, of course you can optimize them out. So what are the magic?
So if a ladder class comes in and tries to access those, you will inflate the size of the object?
Yes. And in fact,
the already existing object.
One of the magics of the Azul collector is that it can incrementally, one object at a time, inflate objects on a read barrier. So I don't have to even sweep your heap and adjust all your objects and then sweep your code and recompile everybody for the new layouts. I can incrementally discover that you've got an object that's going to get inflated, and inflate it when it comes, on first touch, and force you off into the interpreter who will do the right thing. And then
so does Zing do that?
It shows up. I'm sorry, it doesn't do it. No, it doesn't.
Okay.
We talked about this a lot. This is, like I said, this is on the table. It's totally doable. Object inflation, and in fact, there's a lot of payoff in existing Java code because there is much Java code where some many fields are never set or never read or only set to 0 explicitly, and they only ever read as 0. So even if you don't bother to deflate the object, you still could optimize the read away and just say, fuck it, you're always getting 0, and I don't care. Until the first write to this field happens with a non-zero value, you're only ever reading a 0. And I'm going to optimize for that. But then the next obvious thing is to say, this object's fat by X many value fields. On the next GC cycle, I'm going to give you 2 copies with 2 different classes under the hood that you can't tell apart that run to 2 different pieces of JITted code lazily, and they deflate. The new versions all deflate. And then the old and the new objects live on in the same system at the same time, and lazily the GC wipes them to the new state. And then they compress over time as you discover them all. So this is totally understood, and we never got around to doing it.
I wonder what a reasonable syntax is for keeping object API and object layout hints separate. Like, one of the things I like about SQL is I can just write my SQL and not really worry about it. And then once I have an application, I can go figure out what my indexes should be.
Well, there is that in Java now, where you can specify relationships between fields, like what should be close together and what should be far apart.
Is there? Where's that?
Yeah, so it came out of that padded stuff that Doug had. I don't think it's public Java though. So it's in, I'm forgetting the name now of the padded. It's at contended or something like that.
Yeah, contended. I believe it was contended by.
And I think it is public, right? So you can't use a public API to put in the padding, but you can label 2 fields as these should live ideally in the same cache line, or another 2 fields or groups that should.
Well, I've seen all
far apart
for it. Sun Miss contended.
Yeah, if I could give some affinity hints and some anti-affinity hints, I wonder to what extent that makes the need to specify layouts go away.
Well, that will help the non-hardware folks. That's for contended layouts are for shared memory, but not hardware. Forced layout are for people talking hardware below the OS.
C# does annotations to prescribe object layout.
So it's under Sun MISC.
Mm-hmm.
Well,
I thought
it moved in Java 9, I think, and became inaccessible. But the affinity, anti-affinity stuff, I think, is still accessible. Someday I hope to not be working in Java 8. I can use that stuff.
At contended, you mean?
Yeah, well, yeah. At Sun miscontended is available in Java 8, and then because the modularity is not available in Java 9.
Great. Yeah, fine. And then they have extended with tags to say this thing shouldn't be near that thing. So yeah, fine. Yeah, that's a good hand.
I wonder how far you should go with that same thought of, if I have something that's really polymorphic and megamorphic, I'm just going to replace the objects with dictionaries and not have objects. Well, be like, okay, I've got one generic version of this that operates over all kinds of different things because I just turned a bunch of objects into dictionaries.
What do you mean by megamorphic on an object? The usual story is that there's multiple
Python.
classes.
Right. So if I have something and I end up stamping out 13 different versions of that function,
Right. Okay.
I'm going to get a code explosion.
You get 13 pieces of code you hand wrote. That's not an explosion. If you write 13 pieces of code, you got 13 pieces of code you wrote. That's not an explosion.
No, I was saying you just have something generic, and each time I pass a different type through that generic function.
Oh, you're talking
I
for
get a new
AA?
function. Yeah.
Oh no, I was gonna limit you to primitives. I'll just explode you on primitives, and then you go to the generic code for if you're not a primitive. I just wanted to know that primitives could do things like shrink array sizes down because it's bytes, not boxed bytes. Right.
So I'm never going to have a function that ends up being
never,
1,000 different copies of it because there's 1,000 almost identical types that go through it.
No, the rule is I will guarantee you specialization on primitives. I will not guarantee you specialization on things that aren't primitives, but I might specialize. That's an optimization. That's performance optimization. And I won't tell you how much I'm going to specialize up front. And maybe, you know, same as I contended, maybe there's a million billion versions of compiler hints you can throw down that says, please, sir, specialize me. But, you know, the JIT will take a look at that, add its grain of salt and ignore it or not, or do whatever it wants to do. Maybe he specializes, maybe he doesn't. Same as that contended, you know, you just ignore it. You get ping pong contention. The semantics are equivalent. The performance maybe sucks, maybe doesn't, depends on your use case. Hey, I'm running this on an embedded ARM chip. Fuck it, I don't care about contended. It's not gonna be 2 cores on here anyhow, it don't matter, right? Whereas, you know, I'm running on a big box x86 server thing. Maybe it matters, maybe not, I don't know. So yeah, that for AA, it's going to be, oh, Mark just dropped and came back. Whatever, Mark. What happened to you? So yeah, so I think performance hints, but a guarantee for primitives. And we'll see how far I can take that guarantee.
Next topic.
Yeah, exactly.
So we did have. I dropped.
Yeah, he dropped. He attempting to reconnect. I can't tell if he's.
I'm back. I just got to go pick up my kids from school. So, but I will be
not
listening
actually-
from the phone.
Yeah.
So
Off and away
York
to
was
the next-
filling us some
next
stuff. I
thing.
was hoping.
How old are your kids? Too late, you're gone.
No, I'm here. 16 and 12. I'll just be listening as I drive to pick them up, and then they'll be very happy that I'm listening to this on the drive back too.
Oh, okay,
Make them listen in.
There you go. Yeah, I managed to land in a zone where my kids could walk to and from school alongside the creek behind my house. So I didn't have to drive them from middle and high school on.
I gotta
Same
say,
with my 12-year-old, she'd be happy to listen. She actually did a commit to Ecstasy, so her first open source contribution.
Excellent, excellent.
And like the fourth Ecstasy committer. So I think we fix the typo in some talk.
Yeah, right. Yeah. I couldn't get my kids like anything but what Dad does. You know, I could not do what I'm going to do. No. The
like
attitude's softening a little bit now, but growing up, nah, nothing that Dad does.
those are my commitments to Golang. They're all like minor fixes to the documentation.
Somebody has to do it.
In this doc, you gave an example of a lat long. Your example was IBM headquarters, but you had the sign flipped the wrong way, so you were on the wrong continent. I flipped the sign back. Now it points to IBM headquarters in the example again. Committer to Golang.
What is Golang doing, including IBM headquarters? Fine. As opposed to Google headquarters. Fine.
That was the other point in the example.
Oh, okay, fine.
I told it was originally Google and Apple, but they changed it because they figured they didn't want to poke anyone.
Go? Does anyone at Google actually use Go?
I see it on Stack Overflow a lot.
They use a lot of Go at Google.
Okay, yeah. I would think so. I thought they would have had that discussion internally before they decided to go whole hog on it. They went pretty whole hog on it, so.
The interesting thing is that leadership really likes Go, and we've seen Go adoption, and leadership was not particularly interested in Rust, and Rust seems to be appearing in more and more Google
Oh yeah,
things.
yeah. Rust is making some headway. There's definitely there. Yeah.
They basically introduced Go to solve their problem of C++ build times that took half an hour per file. And it turned out that Go has largely been getting traction on things that were written in Python and needed more performance. And the actual C++ problem has been getting Rust. And it's been interesting to me to see that Rust seems to largely be eating C++'s lunch, whereas Go seems to be eating Python's lunch.
That's
That's what I've seen as well. That's what I've seen as well.
I don't quite know why that's true.
I would claim that those languages, like dogs look like their owners, those languages like Rust has the complexity that you have to have your head that you can wrap around, and memory management, you have to wrap your head around, but it's a better way to do that than C++. And I would claim the Python guys have a very simple syntax they really love, and Go has a very simple syntax that they can get into. C++ syntax is baroque beyond belief, broke and baroque both. So if you're not into that, you're not into that. So I claim there's a I don't know if languages look alike or dogs look alike or whatever, but I claim there is a thing there.
I think for the organic developer adoption, there's like this one rule of programmers don't like to downgrade their language. And it's applying it to like the last 10 or 20 years. It works out pretty well.
Yeah.
Well, I think it's like if you're like a C++ programmer and you love the fact that like there are maybe 5 people on the planet that understand the language, then you're not going to a language that everybody can understand, right?
But you're not going to Scala either. So there's another notion there, right?
No,
So
but
almost
Scala does not appeal at all to a C++ developer.
you can't
just
demand performance by nitpicking your way through it.
Just because the examination of Scala doesn't allow you to prove that Bjarne didn't design it.
No, I don't think they're beyond designing it. I don't think that's the case.
I think
about the whole kitchen sink thing.
I think the usual lines, like the usual language lanes, still apply. I think it's like if you need the control and performance of a native language, you won't switch to a JVM language. And
but Scala really did appeal to Java developers who wanted more stringent support from the compiler and the type system. And Java, of course, has been changing to try to steal all those things from Scala as well. But I mean, Scala early on really appealed to people who wanted a better type system.
Scala really paved the way for the functional idioms to come to mainstream languages. That's for sure.
I think the Java people back in the day hadn't really that much of a choice if they wanted to stay on the JVM and wanted to have a better language. So yeah,
but that wasn't actually my experience with Scala. Most of the people I know who got really like go Scala were people who were coming from Ruby. And were like, I really loved Ruby and the flexibility and all of these types, but also I realized that I'm spending most of the CPU cycles in my data center doing stack traces that then get thrown away. I need a VM that actually like can optimize things.
And then the Haskell developers, when found out that Scala can do some of their stuff, a flock of Haskell developers come to the Scala community.
Oh, really?
Yeah.
Okay.
Yeah, I think there are multiple factions, and most of them hate each other. So
yeah, of course.
There's also a Haskell implementation on the JVM that's faster than GHC apparently.
Yeah.
Really?
Yeah. What was the language? Elixir? No.
The Haskell implementation, there is Frege on the JVM.
Frege, yeah.
I thought the Haskell implementation, not on the JVM, the core one, I thought that was considered pretty good.
Yep.
LLVM based, but it doesn't. It has a very hard time optimizing.
Okay, fine.
And so C2 in Hotspot can optimize Haskell pretty well because a lot of its stuff
Well,
it sees at runtime, and it's like, I'll just inline 40 levels of this, and poof, it actually runs okay.
I thought
Actually-
that Scala guys like Martin Ordersky spent a lot of effort baking the Scala down to decent JVM bytecodes. Like they baked away much of the functional. I see a lot of, no. You make shit JVM bytecodes.
Yeah.
No, I've looked at the bytecodes from Scala, and it's not pretty. Well, at least
Fine.
a couple years back, 3-4 years ago. It was
I got out of that game while, I mean, I knew it wasn't pretty at the time I got out, but I knew they were working on it, so I was fine.
So I was analyzing some of the ways it was generating, simple expressions, and it's like A plus B was like, okay, I need a temporary for A, and I need a temporary for B, and then I'm going to have a temporary for the result, and then I'll move the temporary into the temporary into the temporary into the actual register.
The initial bytecodes whose Scala C which emitted was terrible. Then the next generation of backend emitter called Gen Code B. That's a different backend for the bytecode emitter become a lot smarter about the code.
And when was that? Was that a couple years ago?
214, 215, something like that.
Some years ago.
No, the Gen B code is older. I think could be the 211 or something.
Maybe.
I mean, my knowledge of people complaining about Haskell is fairly old, but the one I used to hear was just that the compiles were slow because the functional stuff blew up and then the optimizers crunched everything back down. But it was like,
but then you
actually,
why did my code have to get 30 times larger to then be compiled back down to 1.1 times the size?
From what I read, actually Haskell compiles to something called C++ upon the C++. Yeah. Yeah. And
But going back on the poor bytecode quality emitted by Scala C, in the end, I think in the end you want to have good bytecodes, but if you're basically never willing to compromise how your language looks like, there's only so much you can do. For instance, like Scala has dozens of visibility or accessibility levels that you can't express in Java at all. So fun things happen. Or for instance, if you have like a nested package in Scala, which means A.B, it's really nested, which means like if you're a class in package B, you're also a class, you're basically also inside package A. But Java doesn't agree with that. And there are a lot of mismatches which don't bring too much benefits to the table, but are really painful in the sense of, okay, this is some kind of special private, but in the bytecode it's public or something like that, or they have weird ways to initialize traits and classes where you end up with public setters for things you declared as final and private in the code. And if you're not willing to compromise on the language level and you're not in control of the runtime you're running on, then you're going to have a bad time. And
the visibility won't impact your code very much. That's okay. I tried at H12, I tried to use Scala to do tight, hot inner loops for simple like Daxby, Saxby things. And I couldn't get them to run within a factor of 2 of Java with all the specialized me and inline primitives and all the magical things you're supposed to do to make Scala code run fast. Still 2x slower than Java code for doing a simple Saxby, Daxby loop.
Yeah. Actually, Scala 3 can help with this because you have a really inline code.
You really get it to boil down.
The inline, it is actually inlining. It's not prescribed anymore. It's actually inline.
The issue I was running against is I couldn't make him not allocate a wrapper, no matter how hard I tried.
Yeah, the inline will help with that, I believe.
Yeah, okay. Well, a little escape analysis would help too, and not very much, just a little bit, but something would have to help there. All right, I got a new guy who just texted me this morning, last night, showed up. Smith, I don't know if you can hear me. I see you're not audioed on, it's fine. You're being recorded live. Don't like that bailout.
Yeah.
Otherwise, look for a video with your name on it showing up on Twitter within the day.
Yes, I'm a university graduate and I feel a little bit overwhelming joining this club because it's pretty obvious that you all are at the top level and I'm just a university graduate, but I'm really passionate about JVM and knowing how it works under the hood. That's why I sent you a message. I tried to look up the information online, but I didn't find much information on that.
What's your question?
So well, my question is that, is it true that first we compile the Java file and it generates a byte file, which is a .class file, and .class file at runtime is loaded as a C++ class, instance class. It has other subclass such as instance reference class, instance class loader class, and which contains array of methods, constant pool.
Are you asking a question that you understand the process, or you have something specific about the process that's going on?
I don't understand like how it compiles or how stack frames works in this process and all.
Yeah. So what you said so far, as I heard, was all correct. So there's definitely multiple layers. So Java C goes to Java bytecodes. JVM doesn't run Java. JVM runs Java bytecodes, which means it runs Scala and it runs whatever, Groovy and Ruby on Rails and Python, whatever. It runs whoever's got language translators runs JVM bytecodes. Okay, now what's JVM bytecodes? Well, it's a text file called a .class file on disk. So you start by reading a class file. Now a class file's got a lot of structure to it, so you break it up much of C++ thing. So the JVM is a big C++ program. So C++ classes for everything. Yeah, it teases apart a class file into its component parts, puts them in C++ structures, so C++ code has a reasonable chance of understanding and manipulating it, and then begins doing things, breaking out the bytecodes from the type descriptors and running the bytecodes in an interpreter and all that kind of stuff.
Okay, so the bytecode invoke virtual, invoke static, all those bytecode calls these methods in JVM at runtime in the hotspot JVM.
No, you're sort of in the right direction, but not quite. So the bytecodes specify a program semantics. Always in the lane of compilers, there's the as if rule. If you can't tell within the program semantics how the implementation's done, you don't know, you don't care, and we're not going to tell you, except unless you get under the hood and stare at how the sausage is made in the sausage factory. So the interpreter runs the bytecodes. Okay, how does it run and invoke virtual bytecode? Well, at its core, the interpreter is written with a dispatch logic bytecode by bytecode, and then within a bytecode, it does a little bit of machine code, so handwritten machine code. The whole glorious things that an invoke virtual does is like huge and tremendous, and nearly all of it only happens rarely. So the interpreter all has tests for the rare cases, like I've never seen this class before, I have to do an official class load. At that point, it switches from machine code or assembly to calling C++ code to do the big complicated thing. The 99% case for the interpreter, the invoke virtual passes all tests, and he just does a little bit of stack shuffle to do arguments passing and goes the next step in the bytecodes. And he's all done in 10 clock cycles or 20 or 40 or something. When the invoke virtual gets handed off to the JIT, the 99.99% case is it turns into an inline cache, maybe. It might disappear, might get inline entirely, disappear, be no call at all, might be an inline cache, it might be an x86 static call bytecode, single x86 instruction, which is 1 byte bytecode for a call and a 4 byte offset that can be handled in half a clock cycle on an x86, that plus 4 other instructions on an x86. So what the implementation is, all over the map, varies, and you're not, as a Java programmer, you don't know, you don't care, you don't see. You just like the end product, tastes good, runs fast. As an implementer, yeah, there's a lot of different implementations. There's the one the interpreter runs, there's a run the C code can run, there's the run the JIT runs. So that's the answer.
So Smith, is that how you pronounce your name, Smith?
Yes, sir. That's correct.
Please, no, sir. Oh, goodness. So there's a PDF you can download. It's called the Java Virtual Machine Specification. And basically, it shows what all those instructions are, spells them all out. Like, for example, the most common one is push.
Yeah.
And then there's pop and there's add, right? So if I want to add 2 values, basically I push the first value, I push the second value, I add. And if you look at the bytecode, I'm going to make up numbers because I don't remember off the top of my head, but
we can
say
go find the
17
stock,
is
though.
push. So say 17 is push. So you'll see a 17 and then a number that references the register. Then you'll see a 17 and a number that references the other register. So A plus B will look like 17, 5, 17, 8, right? And then you'll see an add. Say add is 25, right? So 17, one number, 17, another number, and 25. And that means add those two numbers and put that value back on the stack. So then the thing after that will be pop to take that value off the stack and put it into, say, C. So if C equals A plus B, that's how it would compile. So basically, you look at that Java language, sorry, not the Java language,
specifications,
Java virtual machine specification, and it'll spell out all those instructions and how they're supposed to work.
To use English as the main language, press the return key.
Oops.
So
It's important that specification is about a stack machine. It's
Yeah.
Yeah.
The actual JIT code obviously does x86 register. The spec says stack machine performance.
yeah, that's what I'm confused. So it says it's a stack machine.
Yeah.
Now I already know that what bytecode does basically. The per method there is a stack frame and there is a local variable array on the 0th index. For invoke virtual, there is always this pointer in a 0th index, which gets loaded on a stack.
Yeah.
So and all those bytecode gets compiled to assembly.
Yeah.
Oh.
Yeah. Lazily, slowly, incrementally, but yes.
Oh.
So a Java program compiles to bytecode, then the JVM executes the semantic equivalent of the Java program, however it chooses.
Right. However it chooses is the key, but it starts interpreted and then it lazily gets JITted.
Oh.
Sometimes JITted multiple different times with different levels of effort to make better code. So that answer your question?
Yes, absolutely. Yes.
An introduction of I don't understand it. It sounds like you got a pretty good grasp on it already.
No, yeah, right. So what you wrote in the Twitter message I got was, pretty good handle on what's going on with the C++ code to get the semantics loaded in from disk and into a JVM. But the next step is how you actually start executing stuff. If you're looking to go figure out how this all goes,
the university I come from is not very well known and the professors aren't really good. And I always wanted to learn about the JVM also. One day I just ended up looking up the GitHub code and I read through I went through the entire hotspot directory of JVM and I figured out all this stuff by myself. Then one day I came across one of your YouTube videos. Then I thought of sending you direct message.
Yeah.
And it went pretty well. So thank you.
Yeah.
Cool. Welcome.
Yeah.
I mean, just grabbing the C++ code and reading it is not the easiest way to get to understand a JVM, but if you really want to understand it, that's
a hardcore way to get going.
Yeah.
So
that's how I actually figured out everything. Yeah.
Good luck with your university program.
Yeah.
And I'll send you the invites. You're welcome to the group. I'll send you invites until you quit showing up for a month.
Yeah.
So it's all good. All right. Next question or topic.
So I have a pretty pedestrian topic because some of the time I spend working on languages is also like focused on the front end. So of course syntax plays a role. And recently the question was, okay, the smaller the syntax is, the less work I have to do to support it in the IDE and fewer effort for tooling and so on. And the question I came up with was, okay, we have like this if then else construct, and we have this construct called pattern matching. And wouldn't it be nice if we were able to put one inside the other, or basically get rid of one syntactic variation without losing expressiveness.
I think
And
you can do if with pattern matching, no?
yeah, and I'll try pasting something into code section of the Google Docs. So basically, if this is your if expression, and this is your pattern matching expression, the core thing, the core insight I had was basically in pattern matching, you have your condition broken into multiple parts, into a shared part, which you inspect multiple times, and into branches. And in the if case, the condition is always restated if you have like an else if and so on.
Oh, insert
And
a code box.
sorry?
I want to insert this colored code box. So I want to make parallel AA code here.
All right. So what I came up with is basically a mixture which uses if, but it could also use match or switch or anything. I just used if because it's slightly more familiar. And the core idea is saying, okay, I have like this this condition, and let's just pretend I can continue this condition on a new line, but every new line I make, I refer back to the shared part of the condition. So I'm basically starting out, I can basically start out with something that looks really simple, like a standard if else, and can gradually extend it to deal with more involved cases like pattern matching and destructuring. And I found it to be pretty neat. I didn't see it done this way, this exact way
You're
before,
asking?
because of course, yeah, I feel like in Haskell, multi-if, or in Lisp, various ways, but I found it nice, and yeah.
You're asking to eliminate the if else construct instead of and replace it with a pattern matching one. Is that correct?
No, it was just I had just wanted to show some thoughts on how you can do it, and
Right.
Yeah, that's certainly one way to do it. Yeah.
So this is dot dot dot. Actually, I would use a single dot because I like dot 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 for not yet implemented.
Yeah, that's I found it a bit difficult because like you could and then in a new line you could basically go on with like a method call which also starts with a dot. So one would have to.
What language are you basing from? I'm using dot for like the this value. I'm intending to use dot for like the this value in a method call. What language are you basing on from here?
In the code examples above. Or
I'm sorry, what?
In the code examples above, or?
Yeah, well, whatever pattern matching you're talking about here. Oh, look at somebody did an arrow Unicode substitution on me. So that actually looks pretty good. And then something with underscore here is always for the -1. So I wrote some code that I don't claim is AA. I'm fooling with your syntax.
The replacing with arrows to me isn't as annoying as what they've done to the @ sign recently.
Oh, I haven't looked at the @ sign here. That's an independent thing. Oh, well, that's just it triggers for all you get the nasty. Yeah, that's that one. I have to turn that one off, and like doing a damn README docs or whatever, I have to go turn that guy off. Yeah, I'm fooling with alternative syntax there. It kind of looks reasonable. There's something to do there. See your dot 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 versus dot.
Yeah. Yeah, you could also like use an underscore and pretend that it's almost lambda or something. But yeah, I found it nice because it's like a very subtle way of introducing or of extending something that looks like a normal if then else statement with like a bit more power or a bit more expressiveness without telling people, okay, there is like this completely different syntactic construct with different rules and everything.
Right. Right. I'm using the question mark for the start of the conditions. Then I was using colon to separate conditions. But
Can
you
you
actually you have something different here.
introduce?
You want to have a match, a common match part show up in each of the guard expressions.
Can you introduce unrelated guards that that has nothing to do with the what you were matching on? Scala can does this.
Yeah, well, so in my case, I used an underscore, which is an unrelated guard. That's always true, which I guess for me, always true is just one. But maybe, you know, you could have, I don't, so the concept here is the guard piece, the common shared piece has a short version, like the word it or a dot or dot, dot, dot. That means take the matching expression, just substitute it as a temporary variable in place in each of the guards, wherever you see the dot, 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 or whatever. Like you could have it in there twice, right? There's no reason not to. Here's a version where I use the dot for guard twice. So I'm going to grab character 0 dot is, you know, uppercase, and dot is unequal to whatever. I don't care. I did a bad guard, a stupid guard, right? But the point is that the dot, which I'm agreeing with you, is kind of disappearing in the noise. Maybe it's the wrong token.
Yeah,
I repeat it multiple times.
I considered being able to use it the way you described. In the end, I didn't go that way because I felt it's like I felt it was like a bit more restrictive, but also stayed more closely to okay, just take this if, put a new line in between it, and then you're almost there. So like the dot 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 has not is in that sense not a special identifier, but it's like in the syntax I propose, you could also leave it out because it's a visual indication, but it's not intended to be a identifier.
So in AA, I can introduce temporary variables at any point. So
you can bound any identifier later in the code.
Right. So right there at the point you put the predicate, I could
say. I've got to say the one character temporary variable does look better to my eye than your dots did.
Yeah. T equals whatever expression ABC, and then the guards all have the T now. Actually, yeah, I'm like, that's even less syntax because it doesn't introduce the concept as a new piece of syntax, which is
but can you bound a different identifier for a different case analysis here?
No, there's no bounding of an identifier for pattern matching. So these patterns, so that's a good point. So there's another version of this that says I have an actual pattern I want to break out. So you know, in the case of I'm going to replace ABC with like a result. Where result has an OK and an error, and I want to say T dot OK of val goes to, you know, peel out the val, and T dot error does something else, blah blah blah. I don't care what. Where there's a pattern match where you break out result being a tagged union with an OK and an error. And that's one of the common pattern matchings you do is tagged union breakout.
But you have to be careful to distinguish what you introduce or what you reference, like capture. That's its outer.
Right. T is introduced variable. Val is a immediately declared variable on the spot. So it's a
Okay.
So not oh, I see what you're doing. Ooh, val is no. Okay is the tag. So the problem I have here is, so I said T equals result. So it's really T equals something that computes a value of type result. Now, type result has two tags, an OK and an error. So you want a pattern match on the tags. Or I have a type which has 5 or 10 days of the week. So I'm going to replace this entire expression. I'm going to start new expressions, days of the week. I have D for day is something that's typed day of week. I want to break it out. So now I want to say D is a case of a Monday, right? And I don't know, D is a Monday.
That's
And do is
yeah,
just a crappy
that's
thing. And D is a Tuesday. Okay. So there's that version. Those don't have any parts broken out on them, but that's another one I want to do here. What's a enum, a common enum that has parts? Cards have a number here. I'm going to do a card deck of cards. Sorry, I'm.
I did
Yeah.
cats and dogs above. I can copy it if you want.
Oh yes, have names
Yeah,
and tags.
but-
Oh, that's a
but-
good one. Okay, we'll do that.
That was an interesting insight I had because if you like fuse pattern matching and if then else, the actual act of pattern matching needs to be represented with some kind of keyword or some kind of syntax in the individual branch, because you can't look at the match keyword anymore and deduct, okay, everything that goes on in the different branches is per default extraction or
that's why every use
yeah.
case, every pattern has a keyword. Scala has a case, every language has a, for each individual use case has its own case word to distinguish what the pattern is.
If is a particularly weird construct because you can't write it as a function because one of its arguments doesn't get evaluated.
Right. So and or it has lazy evaluation terms.
I would argue that in most languages, like this case, for instance, in Scala, it's a syntactic concern. You wouldn't technically need it. It's like you could.
I argue that is absolutely needed because you have to disambiguate with where the case pattern start of the, where is the case pattern of the pattern matching starts. That is why you need some keyword or some syntax to distinguish from now on. This is the first use case. When you encounter the next case, this is the next case in the pattern matching.
Yeah, but you can use curly braces for that. It's like there are multiple options for that.
Yeah, of course.
I'd say with this different approach I'm toying with, it's absolutely necessary to actually have a keyword. In that case, like replacing it with curly braces is not possible because both the pattern matching and the non-pattern matching branches both use the same syntax intentionally.
And we hit another use case pretty quickly. Actually, the bounding of the variables requires you somewhat to have a case to have a keyword before, because it will pretty quickly you will not be able to disambiguate what you are bounding inside the pattern or what you are referencing outside of the current scope in the pattern.
But syntactically, it can look like any other function. It's just a magic function.
Yeah. Nothing prevents it from.
Yeah. I think for this case, I'd go with some of the newer languages and mark the bound variables explicitly. I did use let in my case, but it could also be @ sign. That the decision of I think, for instance, Scala, where random things bound where random things inside the pattern match were bound automatically was not ideal. I think it's like they had this little hack with like if it's written lowercase, then it's bound, and if it's written uppercase, then it refers to some context around it.
The case, it's certainly not ideal. I would agree.
But
I'm staring at this, trying to sort out myself what.
In AA, if I have something that's one of 3 types,
right,
and I want to disambiguate it with ifs, what is the syntax for is-a?
Well, right now I don't have an is-a. Oh, you mean like an instance of test?
Yeah, I know you were talking about like a colon less than at one point to be like, this is inside that.
I haven't sorted that out. So that's a reasonable one. Colon less than, colon greater than being instance of. Maybe that's where it goes. So I would say I have a actual value on one side. I have a type on the other side, and I'll do an instance of test with something. You're asking an instance of test. Then as soon as you're on the true branch of the instance of, I automatically upcast you to that type, and you can use it as that type.
So that seems like a reasonable way to do results.
To
just say a result
yes.
A result only has the fields that exist both on the error case and on the OK case until you do an instance of.
Okay, so actually that's not a bad answer. So that's a one that says for result, which is a 2-entry guy, I'm going to claim that I know that it's 2-entry. As soon as you pass the first one, the alternative is already upcast to the only remaining value. So let's put this as a cast notation here. So I'm going to say, is T an instance of however that syntax says, a result.OK, or result.OK is a subtype of a result. Okay, well, in that case, I'm just going to use, I don't want another T, I want a little T here. Thank you. I'm going to use immediately, it's whatever I do over here. I do things with T as the OK bar. So I can say T.val, do something. And otherwise, I'm going to do, see, this is a bad syntax here. Get all this, colon, T dot error, Okay, so no curlies. The curlies are optional. You can put curlies or not. I don't need curlies. So
only if it's a multi-line statement kind of thing.
Yeah, I can make a multi-line. This is just a standard if then else. This is a version that I'm expecting for 2-entry guys or 2-valued tagged unions. I'm expecting to do something
like in
this.
C ternary syntax.
I'm sorry, it's a ternary syntax.
Ternary syntax.
Yes, standard ternary syntax. There's an if test, which is completely standard if test. That's just a colon greater is a. I'll replace the word is a because whatever the hell. Then in the true arm, you're a result.OK, which has a val field, and in the false arm, you're a result.error, which has an error field, and that's the tag unit disambiguation for 2 entries.
So
oh, go ahead. Go ahead.
Oh, sorry. So would this only work for types which have like exactly 2 options?
Yeah, this works.
Or do you have like multiple options, and with each check you refine the remaining types down to a new subset?
Right. I don't like that syntax because that just begs exactly for a pattern match you're talking about, which is exactly the breakout that you'd rather have a special syntax for. I, in theory, could have the typing system be aware and subtract entries as you test by and upcast as you go, but you'd have to repeat the test. Exactly what you were saying. I don't like repeating the test. The test is not, are you a result.OK? The question is, which of several of these cats or animals are you? Right. And then if you're a cat, you have a meow. And if you're a dog, you have a tail wag rate. Every animal has a name, but my parakeet has speech volume. I don't know, whatever the hell. Right. So all of these breakouts want to say start from some guy and then do an instance of breakout test or a series of arbitrary guards. Like you wrote some examples of some semi-arbitrary guards. Hey, is it equal to BCD? Is it not equal to ABC? Is it got a size of that's greater than 3? There's a bunch of things you might want to have for arbitrary guards. Yeah, the 2-entry guy says is a result.A, else you're a result. Yeah, you're breaking it out to result. This is the instance of tree that I don't like the syntax of. And I do this crap in Java all the time, and I hate it there too.
But if you have a return value and error value, you are forced to examine both.
If you have just 2, you don't have to test them both. Like I can tell you if you've got a closed tag union and know that you've tested some portions of it. So I don't have that implemented, but that would be a standard straightforward extension, would just be to count the number of tags that are possible for a value in a tag union.
Yeah.
And then exclude as you go so that the last guy doesn't need to have a special if test.
You will have some exhaustivity check for a totality. You cover all the cases.
Somebody's trying to spell default with like German or something spelling there. You're getting closer. Who's anonymous chipmunk? Here you go. Yes, right. And then I don't like that syntax. I think that's correct syntax. I should be able to make and parse and implement that. That should work. Not good looking. There you go. Yes, not good looking. And then I want a version that does something closer to what Simon was saying, where you ask a question about T's type once, and then you have a result.A, result.B, result.C breaking out everywhere.
Well, the main thing I want from the match is not just that it's prettier. I want it to say, dude, you did not cover all of your cases.
And didn't cover all your cases. Yeah, yeah. Like the if then else, there's no requirement that the else clause, it's going to cover all the remaining cases,
Right?
However many there are.
If I have a spot where I reach a thing that is true, false, or null, and I say, here's the true branch and here's the false branch, and it goes, dude.
Right, right. And you want the compiler to complain, I didn't cover all the cases. Totally. I got days of the week. I went Monday, Tuesday, Wednesday, da 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 da. Oh, you forgot Friday, right? You know, give me a complaint, damn it. Yes.
Yeah, I would expect that if you extended if or whatever it's called that way, that you would have to add exhaustiveness checks. My question, but the thing I'm wondering there is whether the decision whether to apply exhaustiveness checks or not would be sufficient if one looked at the type of the shared part. So not sure if there are gaps or missing pieces, but like sorry?
What I just heard you say was, if you do an if test, a standard normal if test never does an exhaustiveness check. If I have something that looks like a union breakout or an enum breakout, I want the exhaustiveness check. And I think you want a piece of syntax that says, and here I demand an exhaustiveness check.
The thing I'm wondering is whether if I say, okay, you get the exhaustiveness check if the condition you're checking against is of an appropriate type. For
And
instance,
I'm saying
some
no.
kind of
You get
enum or boolean or int or something. And I'm wondering, like, would this be sufficient?
Right. I'm thinking I want an exhaustiveness check to be coupled with a special syntax, a matching syntax up front. If I do an if test, I am not demanding exhaustiveness, even if I have a small count enum I'm doing breakouts on. If instead I switch to the pattern match syntax, whatever that is, I am at the same breath asking for an exhaustiveness check. So I must have an exhaustiveness check, which doesn't need anything if I've covered all the branches, but I have to have a default case if I haven't covered all the branches, so I get a compiler error. And I need it, and therefore I need a separate syntax. If somebody used question mark as the version of an if test that demands, for instance, an exhaustiveness check. And if A, B, C cover the cases, we're done. And if there's a missing case, the compiler complains. And if there's a default flavor you haven't mentioned, and the default flavor is your exhaust and covers all the remaining. So I think that, but right up front, there was a demand with a special syntax, a double question mark, saying, and do the rest. Yeah, now you should keep your syntax the same. Do an underscore question mark, or the number 1 for AA, which is always true, or whatever. You have a test value and a question mark and a block. So do something with a question mark, underscore true, yes, with a question mark and then a block. Yes, that's your in the default's actually code. Yes, it's whatever code you put for the default case, which can be empty if you want to blow off the default case.
Wouldn't it be necessary? Wouldn't it be sufficient to decide it based on the existence of the else branch?
And
basically saying, if the type cannot be exhaustively checked, you need an else branch. But if the type can be exhaustively checked, you are forbidden from using the else branch, and you need to be exhaustive. So
okay,
right, but you can't just use true as that special case.
Yeah,
if my last thing is true, I'm always going to get caught at true. Then I'm happy.
Right. So you don't need to force the lack of a default or demand everybody breaks out every case, because you definitely want a default. If I'm doing characters in a character class thing and I've got lowercase and uppercase ABCs and zeros and ones and whatever, I end up with a large class of characters I don't fucking care about. I want them dumped into the default case.
But in that exact case, I could imagine that, like, I'd say it's like so uncommon that it's probably fine to have like some kind of annotation or something.
No, I don't know. I'm hitting that kind of thing now. I have a large, complicated typing lattice certain type elements contain other elements. They participate in a cycle. I have to do a DFA minimization on these classes of guys, but not these other classes. Ints and floats don't need to participate in DFA minimization because they ain't got no fucking.
But would it hurt to explicitly write them down?
It's just another. That's what I'm saying. It's just another pile of complexity. I have a subtle, complex algorithm. I don't want to add any redundant crap that no one cares about. I just want to say, and by default,
there's an interesting question here, which is, does your syntax require you to say else on a if?
That's what I'm hearing, and I say no, it should not, and it doesn't for AA. My if then else specifically does not require you to specify an else.
That only works because you have a null.
I have a value for what it means to be an else. Yes. But you could do the Java doesn't require you to have an else, and it doesn't have values on if then else's. And it doesn't have value for that statement. But it doesn't, neither does C, neither does a bunch of languages, right? So I have a value so that I can not have an else. But commonly people don't want an else. And if you don't care for the value, you don't assign it to anything, you never got computed, you didn't want it. The fact there was a 0 is non-essential, nothing, didn't imply anything. Like I could demand that all C code have if then else's return a value. No one's actually using them right now because that's not valid C syntax. So no one would care what that value was. So I just would say, I'm returning you only the dead beef as the value. If you write the new syntax, you would see the dead beef.
What would be the return type of a value that doesn't have an else branch?
You get a null.
No.
Yeah. For AA, you get null.
So okay, let's, for example, in Scala, if you forget the else branch, the type of what you are typing immediately becomes any, because the else branch would allow you to unify to something.
And I could go there as well, but instead I say it's a no, because I think that's a more refined, reasonable result. But I could say it's an any.
If it's Scala returning or inferring a unit for that?
Yeah, that's what I just heard.
Any.
Okay.
Any.
It was actually an any.
First any. Yeah.
I could go to any. Units basically for me a nil, but they're pretty close.
Yeah, I don't know why that would return any instead of unit. Unit seems cleaner.
Okay, maybe.
It might be a typing game that had to survive, and that's why they went to any. I do a lot of funny things with nil.
Okay, let me check.
I mean, I think the conflict that we were talking about was when do you demand a completeness check? And I claim I want a syntax up front that says, and I'm also going to demand a completeness check. That's different from the if then else syntax.
I'm claiming tentatively that it's returning.
Oh, you're talking about Scala now?
Yeah. So if I assume that I'm in a language that has macros,
yeah,
and I have an if,
yeah,
and I have some kind of syntax that says this must be dead. If you ever reach this symbol, that better be dead and better be removed by the compiler or it's an error.
Yeah, assert.
Now I can get my matching completeness check by using the macro expansion to get my tree of ugly version of code that I generated from the match. Yeah. And I just put as my last case, if you didn't specify a default, the I must be dead symbol.
That's the assert false.
And
type error me now, which, you know.
Right, it's a compile time assert false.
Yeah, right, yeah. So type error. I've seen people call it fail as a keyword or whatever.
Sure. Do I need any more syntax than that to say, yeah, this is just a macro and the macro does macro expansion and the last case is fail? Well, and if you put the true, then the fail won't be reachable. And if you don't put the true at the end, then the fail will be reachable.
Unpopular opinion, outside of Lisp, there shouldn't be macros.
Yeah, that's a different one. He was using macros as a short, easy, convenient way to write an instance of tree that you didn't have to think about. And then followed by what the hell you do when you automatically expand an instance of tree. I'm of the opinion that I enforce completeness checks happens at the start of the match with the syntax. I want a syntax up front that said, this is a match, matches automatically enforce a completeness. And that happens right in the way in the beginning. You both know it's a match and it has enforced completeness.
And pull that match complexity into the language instead of having it in the library.
Yes. Well, if it can be done with a library, then I'll go there. But I would like the canonical version that you typically write to be, I wrote something that says this is a match, and therefore there'll be a completeness check at the end. And for ifs, I specifically say you don't have to have a then clause. So you can't do it with an if then else directly, because I'm not going to demand a then clause, which means there's a separate syntax.
Right. That's why I need a fail syntax that says must be dead.
Yeah, and fail syntax is easy. That one I'll probably have in there anyhow.
And it turns out, I just tried. It turns out in Scala, Theodore was correct. That's it tries to unify the branches, and the else branch, if it's missing, is unit. So you basically see, if you say if true 2 and nothing else, you get any val.
Yeah.
And if you say if true string, you get any. And that's oh my god, I know exactly why this happens, and it's terrible. It basically infers the shared super type, and because
you're getting any
unit,
because that's the unification of string and unit.
No, if you get any because exactly it's the unification of string and unit, but you get any val if you unify an integer or an int.
What's an unit? Any val?
Any val, any value, any
in a value type, in string, int, long.
Because it reads like unit as a value type during type checking. So the type ends up being different.
Yeah, AA does almost identically the same thing. That is, I will unify the two arms to the lattice elements, and I have corresponding lattice elements for any val, which would be what I call scalar, and any, except that
this is the most sensible thing to do if the branch is missing.
Yeah, I'm using 0 instead of any.
In Scala 3, doesn't even let you type it. It doesn't let you to. It has to be inferable. It has to have a type to give you back. It doesn't let you type it.
So it didn't let you type it. Okay.
Yeah, I think that's a nice improvement.
Well, that just says you can't have a missing else clause. And I claim it's still convenient to have a missing else clause when I don't care, but I want to give you a reasonable default.
Well, if missing else clause, it would push into the direction of a side effect in code, because you don't have a type to return to the user, and the type is nil. And what will you do with nil?
Well, no, nil's
you just need a type.
Nil's the correct response in a lot of cases. If I have a series of tests I'm guarding my way through, and in the end, I'm going to return you a nil if any of them are false, because it's going to mean false. The answer is false. Or if they're all true, I can go to the next guard, to the next. I just have a series of question marks expressions. And when I'm done, if I got a nil back, they were all false. But I marched my way down the set of expressions. So I claim that's a reasonable thing to return a nil in a lot of cases.
Yeah, certainly. It has a use case to return nil.
No, I think it's not has a use case. I think you look at Kotlin's Elvis like thing, it's doing something very similar to that. Let's be just tag question marks one after another with
pipeline
progressively deeper guards.
Progressively define the type. Yeah.
But it doesn't decimate your types because you have a nullable string or a nullable int or a.
Right. It doesn't kill my types because I get a null. Everything's nullable. I get a nullable back. It's all reasonable interpretations of the nullable there. So I get an answer back as reasonable. And then if you want to have side effects at the end, you do. When you're saying Scala is trying to discourage side effects, so they didn't want to have an if without a else, because then you're obviously only in the then clause to do a side effect.
The main point is to infer some type, so you can structure a tower of types. This type goes to this type to infer more structure in the code.
Yeah, right. And I'm okay with. I got my types inferred there as well. Okay, there.
Yeah.
The game I did with Henry Miller and Nil-able is the same game done on the Henry Miller side as Nil-ables and lattice side. It gives me the same conceptual correct type there. So interesting. Yeah, so I don't know what to do with I'm backing out. I'm up leveling here, or reversing it. I don't know what to do with matching syntax yet. Something to do with somewhere to start a match. And then there's an instance of tree breakdown match. There's a tagged union, which is very similar conceptually to instance of tree. There's also just a series of guards, one after another, that have nothing to do with each other.
Yeah.
They're just
one
guards.
One other main point for the pattern matching is to compile down a functional concepts, functional to help compile down a functional concepts like a structural matching of the code of the case classes, sealed hierarchy, etc., etc.
I'm missing.
Scala thing.
Yeah, I heard sealed classes. That's a Scala thing, but you know.
I believe that the pattern matching helps guide a more functional idioms and constructs.
Well, it does in general, yes.
Yes.
Yeah, that's the usual.
That was my point.
Okay, yeah, fine. All right, well, you know, we've been at this 2 hours, so maybe it's time. Oh, here's the Scala code at the bottom. An any val versus any. Yeah, okay.
Yeah.
Do you think it
So
makes sense to be
generally
able to
speaking,
say for this function, don't evaluate the arguments? Just wrap each argument in its own lambda and give me a stack of lambdas instead?
I'm all but there in AA. I've looked at my and or and realized that what I had to do in the parser to make that work was best done by having a tag on your function arguments. And the tag says this argument is lazy. At the parse time, I will wrap it in a lambda and hand it to you as a lambda instead. And then and or become standard user mode functions that just take a thunk, no argument lambda, and they'll lazily evaluate it. So I think I'm going to put that directly in the language, and that will sort out.
If I have the power to say, for this particular function, don't evaluate the arguments, just give me the lambdas.
Yep. Now,
I'm going to demand now just write match as a function.
Yep, exactly. Oh, I see. Oh, maybe.
Now match isn't part of the language. Match is just a function in the standard library that says, give me a pattern and then an action and then a pattern and then an action. And I'm going to go through my arguments, evaluating the patterns and then only evaluating the actions for which it's true.
You know, I might be able to do that. That's plausible. I didn't think about that.
As usual, Scala tried that once.
Okay. So tell me how it went.
I think it was way before my time. They abandoned it. I don't know that much details, but I think they tried it and they then implemented it as a language keyword.
Right. And why? Because it sucked somehow. And why did it suck?
I could imagine that, like, if you're like trying to have it as a normal function, but then still expecting to have like all the exhaustiveness analysis and all the linting and all the warnings.
Compile time exhaustiveness analysis will not come out of this.
Yeah, you could do it, but it's like it's needlessly painful, I guess. Fine. But I don't know if that was the real reason.
Darn it.
I mean, you get runtime exhaustive essentially for free.
You were just complaining about this seconds ago, though. You want the compiler to complain up front.
No, I want the compiler to complain at me.
Yeah. You want it up front. So I claim that won't do it as a...
and it breaks my earlier theory of just put the fail at the end of all of the ifs.
Yeah.
Because there is a good chance that if I hand you a pile of lambdas, you're not going to be able to prove the last one's dead.
Right. Actually, that's a good point. Yeah. If you give me a pile, I can break out closed enums and count them, but I can't do it in sort of a more generalized way. So yeah, if you want an exhaustiveness check, you ask for it up front. I think it has to be that way. And then you have to supply me with the thing that I can exhaustively prove. And if you can't give me an exhaustively provable thing, you'll get a compiler. It's all good.
I mean, you could just pass. You could have a function that takes a function and pass just in match as the function, and then you wouldn't be able to say anything about it.
If I have something and I put it through an if statement that says, if any, take the first branch, else take the second branch.
Yeah.
If the second branch is dead code?
Yeah. If I can prove the first branch is always true, the second arm is dead code.
So in theory, if I had a shrinking type.
What's a shrinking type?
So I have my 7 days of the week.
Yes.
And then I do an if test, and now I have 6 days of the week, and then I do an if test, and then I have 5 days of the week.
Yeah, yes. If the type system understands closed enums and can subtract them when you test for one of the members, I can count them down. And in that case, I can give you the default is correct. You can write it.
Right. Now I can have the only thing I need is a lazy function. And as I go through each of the ifs, it looks at the lazy function and says, yes, this takes one type out of it. And when I get to the bottom.
Yeah, you need one more piece, which is need match to be a hard inline. Like match gets called from many players, and match gets called from all these different places which have different kinds of enums that are coming in. You want in each place him to inline such that I can look at the enum statically, count your cases you provided me, and verify you got them all. Right? So you could do it with match, if, like the primitives I'm talking about. There was a rule that said match will always inline at the call site. Match will then evaluate the guards, and if your last executable guy is fail, you'll fail unless I can prove the guards are complete coverage.
I think if you wouldn't need the inlining if the types of the function you used to match weren't of the general enum type, but of like the specific enum member type you matched against. So if you had like days of the week and had 7 functions, and the pattern matching function for like the first day of the week wouldn't accept like a week as an input value, but would only accept a Monday as an input value.
You've made a match, right? So you made a match for days of the week, and what I heard Aaron talk about was a generic match. It gets called with animals. It gets called with days of the week. It gets called with types of cars. It gets called with whatever the fuck.
Ah, okay. Then we have lost. Then we
right. That's what I'm saying. Now I have to inline to the point where you said days of week. So now that I have days of week, I can now say all of them or not all of them or whatever. Which, it's getting complicated, and then that only in my head makes sense if I want function call syntax. Now my function call syntax is pretty generic, and if you just said the match followed by a pile of lambdas, I could turn that into, and you textually laid it out in your editor politely, I could turn that into a match tree that didn't look too bad. Kind of a little bit dorky. I don't know here. Let me go to the bottom and find a whole.
But I do like the idea of a function being able to say, don't evaluate my arguments. All of my arguments come in as lambdas.
So the Java guys are arguing about this right now. If you read the Amber mailing list, they're doing logging, and they're trying to make it so that the log message isn't rendered unless it's logged. Right. So there's this, and it's anyway, lots of arguments going on, but it is an interesting topic.
In the end, I guess the question is like, well, the thing is that people don't want to write the open parent, close parent arrow thing because that's the only thing that's distinguishes between evaluation and non-evaluation in the simplest case, right?
Yeah, I'm asking for an open paren arrow to get a evaluation. You have to function.
There are write-only languages, and there are languages that are designed to be read.
Yeah, one language is still meant to be read.
The syntax that you're proposing suggests that the caller is passing in lambdas, right? Yeah. Not that the function itself says, I take lambdas and I'm going to turn every expression.
Oh no, match takes a pile of lambdas, which he then promptly eats them one after another, and lazily, and every other one is lazy. So I don't have any syntax for lazy there. Match
that syntax is fine. You don't need the power in your language to say my function treats all of its arguments as lambdas if you just take in lambdas.
That's a good point.
My question was, can I do the syntax where you call it as if it's a totally normal function?
Right.
And I, as the function, say,
right,
instead of evaluating my arguments, wrap them in lambdas and hand them to me.
Right, and what I don't have is a way to have var args where I can alternate lambdas throughout the var args. So here's a version where it's all being passed as arguments, one after another. Repeat ad nauseum. And there's a close paren at the bottom, and I didn't do the middle guy. I didn't do Wednesday. I went to delete Wednesday to make life easier. So here's a version where I took only arguments as a pile of arguments. Now, is this an easy to read match? I'm not certain. And can I make it lazy? Maybe by screwing on var args. If I hand you independent lambdas, I can curry the hell out of it and make it var args with every other one being lazy. That one I can do. I can't do this one with every other one being lazy on a typical var args, but I could maybe figure out how to do it syntactically. But tell me this is easier to read.
No, people are probably going to want to put the ones that are actually code blocks in blocks so that they look like blocks.
And I heard somebody, probably Simon, said, no, it's not easier. Okay, go look at the one up. It says match form with T question, result.A, question block, result.B. I claim that's easier to read. I don't know, I don't know if that's necessarily the final syntax I want, but I think it's easier to read.
I guess the core concern is that if you have a syntax where you can define at the definition side that it's lazy and it doesn't need to be reflected on the call side, then I think my internet connection is down.
Yeah, I got to capitalize because of the free Google capitalization. I did T equals pred so it would have a temporary variable for each of the following pieces. So pred is an arbitrary expression. So I see you getting rid of TE. Oh, this version is the enum only version where the implicit assumption is equal each of the arms of the enum. Which I like that syntax in some case. Like there's a syntax that says I want it everywhere, and there's a version of the syntax that says
it's an implied
arbitrary random guards one after another. If they happen to be picking off cases of an enum, I can get to the bottom and do a completeness check.
Yeah, I would say match and guard can be separate functions.
Okay, so two different versions. So there's a match that says
match implies equals, guard is
right, and a pile of guards. So pile of guards you can do with if then else's with a little bit of clever alignment. If you have no colon, you don't care about the colons, or you do something a little careful with the colons, you can arrange a pile of guards to just be a series of if tests in a row that do something, and the else clause immediately goes into the next guard test.
So we did it with switch with no argument to the switch. So
yeah, okay.
Basically, each case is a Boolean case.
Each case is a Boolean case, and that's just really a pile of ifs one after another. Yeah, right.
Yeah,
and can I unify that syntax and get rid of having a switch keyword just with if then else's? Get pretty close.
Yeah, I'm not sure. I'm not sure if I'm convinced that it was a good decision. So.
Oh, okay, fine.
It's not horrible, but it's not compelling.
Here's two different versions of matching. One which is taking an instance of or case breakdown of a known value, like you're doing an enum breakdown or you're doing a instance of tree, and the second version is arbitrary guards. They happen to be doing case breakdown, but that wasn't there's nothing special. There's no completeness check on the second version. It's just a pile of arbitrary guards.
Yeah, you're not going to get a completeness check on your pile of arbitrary guards.
Yeah, right. And the syntax.
They're lambdas. They can do anything.
You can get pretty close, but in particular, it doesn't have a completeness check. So
why?
In fact, now if I go to this version without the arbitrary guards with just if then else and AA syntax, if I had a version of AA's the ordering of evaluation on question marks or whatever yeah. So T equals pred is easy, and that's just a separate thing. And then it was going to be T equals Monday question mark. ... whatever's going on in there, and then I say colon question mark. So what do we do here? Where do I want to put this guy? Yeah, colon, and then equals Tuesday.
Yeah, that's not terrible syntax. It's just straight trinary.
Yeah, it's just straight trinaries. That's what I was trying to look at. How bad is it? Yeah, that's the straight trinary only version. Other than it wrapping over the damn page because the borders suck. Google, what are you doing here? Oh, look at that. Did that help? What'd you do, Google?
And if I want the compiler to give me some
Oh, no, that's
I don't want this to be, I could do a like bang, 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 this must be dead.
Yeah, and bang, bang, dot, dot, dot means to be implemented, but that's the same as halt and die.
So these just look like switch statements. I mean, if you're just comparing equality and you have a default.
Yeah, exactly. We're looking at how to do, what are the options for syntax for, like, I don't want to, I'm looking at minimalizing keywords. We're just playing with syntax. We want to have pattern matching. We want to have, I have an if then else. What does pattern matching do over an if then else? So give me the best case if then else scenario for doing a pattern match breakdown. Okay, give me a pattern match breakdown. Is it better than a pile of if then else's? Maybe. The pattern match gives me completeness checking, which if then else's explicitly do not. So now I'm like,
well, the else is a completeness.
No. That one is, you provided a completeness. I'm saying the compiler demands a completeness and gives you a compile time error because you didn't cover all the enums. Can you give her the arm? You didn't handle all the enum cases. So I want to have a syntax that says I demand the compiler demands completeness. And if then else's don't do that. They just take as they get.
Yeah, we do that with a switch expression.
Right.
When it's used as an expression, we demand completeness.
Yeah, right. So everything's an expression here. I have to have some sort of completeness, but I want the specific completeness that says it's the pattern match version, which is the one that said match Monday, Tuesday, 1. The match clause said specifically, I want a completeness check. You better have the 1 or you better cover all the 7 days. Whereas the con says, it's just a pile of ifs in a row. I'm not going to completeness check. You might have a complete one at the end. You might not. I don't care.
So Simon, I was going to ask, I mean, the difficulty I've had with the application of this style of construct has to do primarily with types in an OO system, because, you know, what if because your match is not an equals equals. Right? Switch is kind of an equals equals operator, but what if I have take Java has a runnable method interface, right? So I could say, you know, switch on something, and, you know, if it's runnable, I want to do this. And if it's serializable, I want to do that. And if it's externalizable, I want to do that.
Yeah.
Because they're not mutually exclusive.
Oh no.
Yeah, then the first one wins,
Yeah.
I guess. That's at least that's what I've seen most.
If you do,
I'm not a fan of it, but
interfaces.
The first types that qualifies get executed.
Well, he's got a point. So if you're doing classes, then there's a tree. There's no overlap except in a tree hierarchy. The compiler can complain that later guys are covered by the earlier guys, and you probably didn't mean to do this.
Yeah, that is the Scala will complain that the second, the last, or the second, the guy after that guy is not reachable.
Okay. Yes. And then the other version is I'm doing interfaces, which many people can do. And then do you want the compiler to complain you have overlapping interface cases and the first guy will win, or silently just eat it, and that's the semantics. First guy wins. And it doesn't have an optimized test version either. The
it's
test
better
is
to
repeat the ifs one after another.
It's better to tell the user that you are being match a more generic type than a more specific type later, and the specific type wouldn't get a chance to.
As I'm saying, match expects the arms to be mutually exclusive. And the con diversion is pile of ifs, does not expect the arms to be mutually exclusive. It just does the tests in order. And you only need 2 syntaxes here. You need one that's mutually exclusive and one that's not. So pile of ifs is not mutually exclusive, but if you do a match, I claim you're expecting mutual exclusion, and I would demand I only support mutually exclusive variations. I think that's a reasonable.
How can you have a mutual exclusion in a hierarchy of types?
If they are in a tree version, that's a hierarchy.
That you should tell the user that to in order to ensure the totality of type, you have to start from a more specific type, and later in the tree widen.
No, that's an error message. If some guy says I have a generic type, I ask for number and later I ask for integer in the same tree, I'll give you an error, but I might include an error message. maybe you meant to swap these two and do number integer first and then number later.
But I wonder if it's practically doable to actually do this, to find to find the right order and to guide the developer to use this order and actually explaining it's why this has to happen in exactly this order.
Okay. The compiler shouldn't prescribe an order. The compiler should only guarantee that you go from a more specific type to a more generic type in order to test the type.
But when the compiler detects that you don't have it that way, and you must throw an error message,
that's
Simon saying the error message would be difficult to get correct. I claim this is quality of implementation. I'll improve the error messages over time. You'll eventually get a really nice error message like you get out of Elm, which lays it all out as much detail as possible. Hey, doofus, this has to happen this way, or this guy's not reachable.
Maybe does that error message have to be anything more than your IDE grays out that code is unreachable?
Yeah, nothing. It doesn't have to do anything. Error message. Yeah, right. Oh, you got number, you followed by integer. Integer is not reachable. I can silently let it be not reachable. I can complain you wrote non-reachable code. In a match, I would claim you should get an error. And if then else, I'll just claim it's unreachable and I'm going to silently roll on. No
but if you're emitting an error, I would expect that that a good implementation can't get away with letting the user guess. And if you have complex hierarchies, you basically have to decide, okay, from least specific to most specific. Okay, so basically a depth first traversal of the type tree, and that can get rather complicated and unintuitive.
Exactly. If you've got a type tree, you better fucking already have so many versions of a depth first search running around in the middle of your type system already that this would just be one more. No problem.
No, I mean if the compiler tells me you need to have exactly this order, otherwise I won't compile. I think it would be very hard for the user to understand why.
Not exactly this order. I would simply say, you can't put integer behind number because number dominates and you'll never run the integer code. You either didn't mean to write integer or integer needs to happen before number. I don't have to look at all the cases and sort them for you. I could. Yeah. I could give you suggested topological sort. This is just a topological sort of a tree. I just give you topological sort.
Yeah, I would argue that the compiler should tell you which order it wants if it's going to complain.
But there's no requirement that of a singleton order in a tree, because I have number covers both double and integer. Int and double can happen in any order before number. So there are two different versions. I can have int double number, I can have double int number.
That's why I said that the compiler should only guarantee that you go from a more specific to a less specific type. The order between the specificity, it's up to the programmer.
Right. You might want them alphabetical, and you might want to do integers first because you have something else going on in your life that wants integers before doubles. So I'll tell you don't do this and say because it's dead, but I won't tell you.
Yeah, I think it's a fair argument whether dead code in a match is a warning or an error.
I think it's an error. I think
you would say don't compile it.
No, I would claim it would be an error, and and I won't compile it. Yeah, fix that. Because
I was just thinking of all the times when I've changed one line of code because I'm trying to test something, and I'm like, you know what? Just I'm going to put a big case at the top that catches everything and try my thing.
Well, if you have a default at the bottom, but no, if you wrote dead code, okay, that's a fair one. I hate this.
What if I'm testing something? So I'm going to deaden the code that's in all the other cases briefly. Test my thing, learn what I need to learn, and then fix it before I check.
I don't know now. Now I don't know because I do this too all the time, and I curse and swear it all the time.
So getting the question back to Cameron, what would you do?
Oh, I would make it an error because IDEA has this thing where you can select 50 lines and press Command/ and it comments it out like. Sorry, Aaron.
Well, no, it's scattered throughout the code. So I dropped one enum entry because I'm trying to get rid of it. It's never going to get generated. immediately I have 50 switches all throughout that blew up. So instead of dropping the enum, I have to decide I'm never going to generate the enum. And somebody who reflectively counts my enum statements has to be told to ignore this
so
one.
in that case, Cliff, you kind of had a good thing with the kind of the poison syntax, where you could basically say, you know, this part of the enum is poison. You know, I think you called it bang, bang, bang or something.
Yeah. Dot, dot, dot was 2BD. That's, right.
But in theory, if you could poison a type, it would highlight it at compile time, and you could, you know, I don't know.
All right, fine.
There's
something to think about it. I kind of like the thought that it does do it's a bug or compile time error, because you almost surely didn't mean that unless you're in the middle of exactly what you're talking about. I'm doing some stupid ass test thing and I broke something and I want to just.
Oh yeah, I suppose it could be a warning for a debug build and an error for a release build.
Yeah, for example.
I'm not.
You know, the other thing is you want it to feel like the rest of the language, right? So like it has to kind of fit the
yeah, right. The general theme of things. Yeah.
Yeah. So how do you make it seem normal?
At the moment, I'm going to declare error, and if it gets obnoxious, we'll look at what can be done about it. I don't have any match syntax in my language yet anyhow, so it don't matter. When I get there, I think I'll make it mutually exclusive, arms, demand a default, no arm is dead. That's the current design point I'm headed for.
Right now, your logical OR and logical AND are implemented by functions that don't evaluate their arguments, but that's not syntax that you can write.
No, but oh God, it's worse than you know. The and or, yeah, exactly. The and or no, you said it exactly right. As of recently, I all my primitives are parsed. There's a special mode I start the language in where I accept a funny new syntax that turns into a Java class for name. And I jam in the Java class for name implementation into the underlying IR I'm parsing. Once I have the primitives, so add, subtract, mode, all the primitives are done this way. Once all the primitives, including and or, once they're all done, then I go to the normal language parsing. That means that and is implemented in the language as a function that's also known to be an operator, and magically it calls out to an operator that is tagged internally as a Java version that says lazyify your right hand argument. You have to have your left hand argument because I have to use it for evaluating for figuring out which function to dispatch on, but your right argument I can be lazy on. So you can have a language specific way to do it. And there's a comment in the prims.aa file that says, and this should be changed to have a keyword lazy thrown on it, and then I would just get rid of the weird custom hack going on there. So there's a thing there.
As usual, Scala implemented this.
Okay.
And I think the core lesson there was that it wasn't used that much for like useful things, and it made it hard in those not useful cases to actually see what happened.
So
because they had like normal methods, they had they looked like normal method parameters, but because of a function declaration because of the way the function definition was written, some parameters were lazy and
right, didn't work out.
Yeah, it still exists, and I think even a few years ago there was like an interesting discussion if you have like a var arc of lazy parameters, like in which direction are they? Is it like one lazy of like this var arc thing, or var arc thing of like many lazies inside? Yeah, okay. I'm not sure. It's like it wasn't still in the language.
Yeah, it sounded like from what Cliff said that
too successful.
The laziness was per argument.
It's per
not
argument.
That you declare I am a lazy function and I don't evaluate any of my arguments until you ask for it.
No, it's a lazy per argument. But at the moment, the only implementation I have is and, which is both an operator and his right-hand side argument is tagged as lazy. But I can tag individual arguments as lazy as long as I can dispatch on the left, and the type that I get for the function evaluation after that is symmetric for every argument. For all possible things I could dispatch to, they all agree on their lazy or not the lazy. And then I will parse them lazily, turn them into a thunk, life goes on. Is that useful outside of exactly the and or case? I don't know. I could do ifs that way too, once the parser knows about, make an if a function.
And a question that's interesting about these lazy parameters is also how often are they evaluated? That's also a nasty issue that existed in Scala, because they were evaluated whenever you refer to them.
Right.
Well,
for me, I would kind of like my lazy arguments to be evaluated once and then memoized.
Okay, so for me, what happens is they get thunked. The calling function, the target function, the called function gets a thunk. He knows it's a thunk. He does what he does with it. He evaluates it once, twice, a million times. He does what he does with it. Now, and does it 0 or 1 according to the predicate. He's also passes left-hand side predicate, right-hand side lazy. He does it 0 or 1, but he gets handed a thunk. Now, what you gonna do with the thunk? So I could have a thing that said I take an argument which is going to be a transactionally applied in a concurrent system. It's going to be evaluated one or many times until the thing progresses. But I didn't have to put curlies around it because it was done as a free thunk, but it will be atomically updated into the database or something stupid like that. I mean, I'm not claiming it's a good use case, but I'm just saying, you can imagine I'm going to evaluate it more than once. Every time I evaluate it, it prints debug me now as a printout on my log file. So it has a side effect. I'm all excited for it to have side effects. I'm all excited for it to be evaluated as many times as necessary to get past the, the transactional update. I'm imagining a use case. Is it useful?
Yeah, that's kind of fair. If you used to be, I tagged one of my arguments as lazy, and then you called it twice, like that's what your function does.
Right,
and the person who's calling your function, that just is the API to your function.
Right, that's the API, right. I'm putting that up to the function API. And has a as 0 or 1. And furthermore, and has another piece on it, which is I guaranteed you I'll inline you, the and guy, so that the thunk appears directly in the code that's going to be executed or not. And I can
interesting thing you reminded me of when you were saying that. Early on, we allowed a function that returned a type T and took no arguments and returned a type T to be used anywhere you wanted a type T.
Okay. Without the parens, basically.
No, with parens, whatever. But basically, you could pass in an unevaluated T anywhere you needed a T.
Right, but when is evaluation happening? Do you specify it by adding the parens?
No. Right. So there were no parens added. Right. That's yes.
Right. Yeah, and I'm currently of the mode of if you're evaluating a function, there's a parens somewhere.
We found there were a lot of stinks with this particular design, so we removed it.
You removed it, yeah. I do allow a no paren function for a single or a function with one argument. You can just do adjacency, which actually top secretly all functions behave this way, and the one argument is usually a tuple that you wrote after the function, and the syntax is identical either way. And you can't tell the difference. Fine. That's how I do like for loops, where I take the multiple funcs after the for loop. It's just a function for takes one argument, which is a thunk, which is going to value a predicate, which returns a function, which takes another argument, which is the body, and then fine. It does a thing. And so for can be implemented in the language as a standard piece of language code, not as a special syntax. All right, here we are, 12:30, 2.5 hours in. I'm going to claim, victory for the Alliance here on having a good conversation about matching syntax and thunks and lazy args, and God knows other stuff. God, we've been at it a while. Anyone else? Anything else? Till we meet again, gentlemen. Very good.
Bye.
Bye.
Bye-bye.
Goodbye.